Welcome to CSS Development with CSS3. My name is Zachary Kingston and I'm excited to be your instructor. Cascading Style Sheets, generally just abbreviated to CSS, are a web development language which allow us to describe the appearance of web pages. Using CSS, we can create web pages which are more aesthetically pleasing, more user-friendly, and even more intuitive than we could otherwise. Before we jump right into the nitty-gritty of CSS code, I'd like to talk to you a little bit conceptually about CSS's place in modern web development. I should also mention that in order to get the most out of this course, you should be comfortable with HTML code. Now, a fairly standard web development model would look something like this. The backbone of our page is written in HTML. And then where we need to add power and functionality, we can add client or server-side programming. And this is a powerful duo that lets us do a lot of things. But where there's kind of a hole that we're of course going to fill with CSS is form. What does our web page look like? How does it feel for the user to interact with it? If HTML and the client or server-side programming are the engine and the wheels of our web page, CSS is the body and the paint job. Let me give you an example. You probably recognize this web page. It's google.com, the homepage of the internet's most successful search engine. I think it's a really good example because this web page is all of the things I mentioned at the beginning of this video. It's elegant and most importantly, it's intuitive and accessible. I go to Google because I want to search the web and the search bar is right there in the middle of the page. I could never miss it. For our purposes, I'd like to show you what google.com looks like if we remove the CSS from this page. And that's what I've just done. This is google.com as raw HTML, unstyled. I think it's important to point out that on some technical level, this page has not lost any of its functionality. The hyperlinks and text boxes and buttons, though they've moved around, are still there and they're still functional. But at the same time, I'm sure you would agree with me that something very important to the structure of this page was lost when we disabled the CSS. One of the unique challenges of web development is that the end user, the person visiting our website, could be doing so via a number of different browsers. They could even be browsing from a mobile device. And for the most part, we'd like them all to have the same experience. We'd like our website to look the same when presented by any browser. Fortunately for us, at least in this instance, we have an ally in the form of W3C, or the World Wide Web Consortium. These are the folks whose job it is to decide how CSS, HTML, and similar web technologies work. What they do is they publish recommendations, which are specifications that all major web browsers must adhere to if they would like to remain relevant and highly used. This is a really exciting time to be learning CSS because CSS2, which has been around for over a decade, is actually in the process of being phased out for a newer version, CSS3. This isn't going to happen all at one specific moment in time. They're using a module development style where they introduce pieces of CSS3 to the W3 recommendations one at a time. So as of right now, CSS3 color namespaces and selectors are on the official lists of recommendations. But the really neat thing is that browsers implement these modules generally before they're officially recommended by W3C. So that means if we're smart about it, and if we use a couple of tricks, which I'm going to show you, we can access what is essentially the future of web development technology today. I hope you're as excited about learning CSS as I am to teach it. It's a really fun technology to learn because just by its very nature, every new skill you develop in CSS has immediate visual rewards, and that's something that's always motivated and excited me when I was learning something new. In this video, we will write our first CSS code. We will use CSS to add color and a little bit of formatting to an existing HTML page. To begin working in CSS, you're going to need two things, the first of which is a text editor. Here I'm working in Notepad++, a free source text editor which I downloaded from notepad-plus-plus.org. I like this editor because it's minimal, but does support syntax highlighting for both HTML and CSS. In reality, any text editor will do, but you do want to stay away from word processors like Microsoft Word or OpenOffice Writer. These programs will add formatting and versioning information to the text you create that will confuse web browsers when they attempt to interpret your code. The second thing you're going to need to write and test CSS is a web browser. Let's take a look at this page in a web browser right now. Here's the file we were just working with. I've called it helloworld.html. Don't be concerned if your HTML files have a different icon than this. Generally, your operating system will choose your default web browser as the icon for HTML files. It's probably important to note here that you should be testing your HTML and CSS pages in every web browser you think an end user might employ. This is because there can be slight differences between the way that web browsers interpret the code, and you certainly want to be aware of this before someone stumbles onto your page using a web browser that you don't support. Right now I'm going to open the page up in Google Chrome. You can use whatever web browser you'd like. The page should look the same. So here's our unstyled HTML page. It really is just two elements, a h1 header element and a p or paragraph element reading hello world ! It's a nice HTML hello world page, but we can certainly add some pizzazz. So let's go back to our editor. There are a number of different ways to style an HTML page. What we're going to do here is insert CSS directly into the page's header. And we do this with the HTML style tag. This section right here is where we'll be adding our new CSS code. There's one more thing we need to do first though, and that's to tell the browser interpreting this page what kind of styling language we're using, in our case CSS. That's the type attribute, and we tell it text/CSS. Now we can begin styling between the style tag that we've just created. It's finally time to write our first CSS rule, and that's what style sheets are. They're a series of rules which persist throughout the pages that they modify. Each CSS rule has three parts, the first of which is who is this rule going to affect. I think we should start modifying our page with the header element. So let's tell our browser that we're going to state a rule to affect all h1 elements. And that's the syntax for a general rule, just the name of the element that we'd like to write the rule for, and then some brackets between which we can write our CSS code. In this case, we'd like to modify the color of all h1 elements, and this CSS attribute is simply called color. After an attribute, we put a colon, and here comes the third portion of the CSS rule, the value we'd like to assign. In this case, let's just change the color to red. Before our styling will show up on our page, we need to, of course, save the file. And then, rather than opening a new browser or new browser tab, let's just refresh the hello-world.html page. And now we can see that the header has turned red. Back to our code, a CSS rule can modify more than one attribute. So in addition to changing the color of headers on our page, let's center them so they're not off to the left. This rule is text align, and we're just going to give it the value center. While we're at it, we should probably style the main text of the page. So here's the rule for all of our P elements. What I'd like to do is color these elements purple, but I'm going to show you a more robust way to declare colors in CSS rather than picking from their list of predefined ones. We're going to use the RGB function, which lets us declare a color dynamically. It takes 3 parameters: the amount of red in the color, the amount of green in the color, and the amount of blue in the color. These are integer values. The minimum is 0 for none of this in the color, and the maximum is 255 for as much red, green, or blue as you can have in the color. So purple is going to be 255, 0, 255, equal parts red and blue. You may also see colors represented as hex values. This is a base 16 number in which the first 2 characters stand for the amount of red, the second 2 the amount of green, and the last 2 the amount of blue. Just like our RGB function. It's a little less human readable, but the equivalent of 255 is FF. So there's purple in hexadecimal notation. The hex system of color notation really doesn't get any points for human readability. So this might be a good time for me to add a comment to my page. Comments are bits of text that we explicitly tell the web browser to ignore when parsing our code. By placing the word purple between these \* brackets, we designate that it's not part of the code, it's just there for developer reference. It's important to note that HTML and CSS use different comments. If I try to use the \* brackets in the HTML portion of my page, the words and the brackets will appear. I'd like to do 2 more things before we head to our web browser and admire the colorful page we've created. The first of these is to modify the background of our page. In order to do that, we're going to need to access the body element directly. And our rule is going to affect its background color. I'd like the background color to be a light gray. In the RGB sense of color, gray is a color that has the same amount of red, green, and blue. The color 000 is black, and the color 255, 255, 255 is white. So to get a light gray, let's go with 200, 200, 200. The last thing I'd like to address, as you've probably noticed, is that we have 2 rules for the color of P elements. We can learn a little bit about CSS here by modifying one of these rules slightly. Let's change our first rule from purple to be defining blue as the color. Now go ahead and place your bets as we head to the web browser. What color do you think our Hello World text will be? Don't forget to save first. Here is our wonderfully styled web page. I certainly wouldn't suggest that you ever use red, purple, and gray as a page's color scheme, but we have modified its appearance for sure. Also, our Hello World text is purple. If you'll remember, purple is the second rule we declared. This is our first introduction to the cascade of Cascading Style Sheets. What this means is that CSS gives preference to rules that are more specific or have been declared after a previous rule. If we were to switch our purple and blue rules, the P text would now be blue. In this video, we will learn about CSS selectors. Selectors allow us to accurately target elements and ranges of elements with our CSS rules. Throughout the course of this video, we will be modifying the page in front of us so that the words and styling of the text match up. For instance, we're going to make this bit of text red and this bit of text blue and boldface. In order to do this, we're going to need to call upon general, ID, class, descendant, and pseudo selectors. Before we jump into any CSS, let's take a look at the page that we're going to be styling. In addition to this header element, the page is primarily composed of paragraph and anchor elements. Some of these elements are in an unordered list. These elements are all going to be styled blue, and most of the paragraph and anchor elements outside of the unordered list should be styled red. Let's make this our first goal. Generally, with CSS rules, you want to work in broad general cases and then style for specific rules as they come. So let's begin by making the claim that all paragraph and anchor elements are red. To make this claim just for paragraph elements, it would look like this. Now, of course, we could write a separate rule for anchor elements that looks the same, but this is a little less human readable, and if we'd like to modify the rule, we're going to have to make our changes twice in the future. Fortunately, if we simply separate our P and A with a comma, the rule will apply to both paragraph and anchor elements. When reading a CSS rule literally, commas translate to and. So our rule reads, paragraph and anchor elements have red text. Let's take a look at the page. So this rule isn't perfect. Most notably, this unordered list, which is supposed to contain only blue elements, is full of red text. On the other hand, there's one really great thing about the rule we've just written, and that's that it's given us some elements which are completely styled and that we'd never have to touch again with our CSS. That's this plain red text that is the color it's supposed to be. Our next goal now is to isolate these elements in the unordered list with a CSS rule so we can turn them blue, overriding the red text. It's time for a little terminology. We'd like our next CSS rule to target only elements within unordered lists. These elements are descendants of the unordered list element because they can be found between the unordered list element's opening and closing tags. Conversely, the unordered list element is an ancestor of all elements found between its tags. If there's only one layer of differentiation, this becomes a parent-child relationship as well as an ancestor-descendant relationship. For example, this li element is the parent of this paragraph element. The paragraph element, conversely, is the child of the li element. With this understanding of the ancestor relationship, we should be able to write a descendant selection rule, which will apply to all paragraph elements within unordered lists. Descendant selection rules take a string of elements as their input. The first element should be the ancestor of all elements that follow it. So this descendant selection rule that I've just written applies to all paragraph elements who have an unordered list as their ancestor. And of course, we're going to color these elements blue. I'd like to quickly show you a couple other ways this rule or very similar rules could be written. Let's say our unordered list contained more than just paragraph elements. Rather than writing new rules for all of these elements or creating a lengthy comma-separated list here, we could replace the P with the star operator. And the star operator literally translates to everything. So this new rule would apply to everything that has an unordered list as an ancestor. For our purposes here, this rule is probably too broad and would apply to the list item elements as well, which we don't explicitly want. We can also make our original blue rule less general by changing the ancestor-descendant relationship to a parent-child relationship. This greater sign describes the parent-child relationship. It causes our rule to read all paragraph elements, which are the children of list items. This is probably as good as our blue rule is going to get. It's a very specific rule, and it also styles all of the items that we'd like to be blue, blue. So let's leave it like this and take a look at our page again. This looks pretty good. Because our descendant selection rule is more specific than the general red text rule, within the unordered list where our descendant selection rule applies, the red text has been overwritten by our blue rule. At the end of this video, we'll discuss in detail how CSS decides which rules are more specific than others. But for now, and in most cases, you can operate under the assumption that descendant selection rules are more specific than general CSS rules. And class selection, which we're about to explore, is more specific than descendant selection. Many different types of elements on our page desire bold and italic text. Rather than trying to navigate general CSS rules which will select this paragraph element and not this paragraph element, what we're going to do is write a CSS class rule which we can then manually apply to HTML elements. To declare a CSS class, you begin with a period, and then you can name the class pretty much whatever you'd like. I'm going to name this one bold. From this point forward, it operates just like a normal CSS rule. In CSS, to make bold text, we need to change our font weight to bold. Now we can manually apply this class to HTML elements. Here's a paragraph here that should be bold. We insert classes between the less than and greater than signs, which encompass the opening tag of an element. Here we simply give it a class attribute and make the value of that class attribute the CSS rule we'd like to apply. Now I'm going to use copy and paste to quickly style our couple other bold elements bold. Now we're going to do the same thing with italics. Declare class, and our command for italic font is to change font style to italic. Now our header element gets the italic class. What about this element right here, which desires to be both bold and italic? Well, an element can have more than one CSS rule. All we need to do is separate the strings, which declare our classes, with spaces. Swinging back to our page quickly, everything seems to be in order. We've made italic and bold text without modifying any of the other styling on the page, which we were really happy with. 90% of this page is great and finished. The only thing we have left to do is style this text at the bottom, which claims to be green, usually. My plan here is to make this text green, except when we mouse over it, and on those instances, I'd like the text to turn purple. This last element we're going to style is unique. None of the attributes we're going to give it are shared by any other elements on the page. So this is a great opportunity to use the ID selector. ID selectors are a lot like class selectors, but they do have three differences. First, each ID selector should only pair to a single element. Second, each element can have at most one ID selector. And third, ID selectors are more specific than class selectors. So, if their attributes come in conflict with those in a class selector or a descendant selector or a general selector, the ID selector will win out. Let's name our ID selector special. And to start with, let's just have it declare green text. That's 50% of our styling goals for this element. The other thing we want to do is cause this element to turn purple when it's moused over. In order to make this happen, we're going to use a pseudo selector. Pseudo selectors actually modify existing selectors. So in this case, we're going to start with our special selector. You can also put pseudo selectors after general selectors or descendant selectors or anything else, really. What pseudo selectors do is they allow us to tap into the state of an element when certain conditions have occurred. The conditions we can access depend on the nature of the element. But just about every element has this hover condition, which means that the person viewing our web page has put their mouse over top of the element. When that occurs, we would like our special ID element to turn purple. Once we put the special ID tag on that unique element at the bottom of our page, both the special ID selector and the pseudo special ID selector, when applicable, should apply to it. Just like adding a class to an element, we add an ID to an element by using the ID attribute and then putting the ID name between quotation marks. Let's save our page and take a look at its final styling. Okay, the text is green. That's a great sign. And here comes the mouse over. Purple. As promised, we'll finish this video by exploring how CSS determines when one rule is more specific than another. If you remember, CSS gives priority to rules deemed more specific than other rules. I should also mention that if two rules are deemed equally specific, the rule declared later will get priority. For the purpose of the algorithm we're about to employ, comma-separated elements count as only one element. What we're going to do is assign a 3-digit number to each of our CSS rules. In the ones place, we're going to put the number of HTML elements referenced in the rule's declaration. In this case, that value is 1, because p comma a, for the purpose of this algorithm, only counts as one element. For our descendant selection rule, we're going to put 2, because there's both a list item and a paragraph element referenced. In the tens column of our number, we're going to put the number of class selectors and pseudo selectors used in the rule's declaration. For our bold and italic rules, this value is 1, and we give the 3-digit number the value 10. Lastly, as you've probably guessed, in the hundreds place goes the number of ID selectors in the rule. For our special ID selector, the value will end up being 100. The special hover rule has one ID selector and one pseudo selector referenced, making its value a 110. Since this is the largest value, this is the most specific rule and will gain priority over all the other rules. I hope you learned something from this exploration of CSS selectors. See you next time. In this video, we will learn 3 different ways to add CSS to an HTML page. Because these techniques are often used in synchrony, we will also explore how they cascade together to determine the final styling of the page when conflicts arise. You may be familiar with the in-file block method of CSS insertion. In this method, a style tag is added to the page's header. And any CSS rules that we declare within this style tag will automatically apply to this local page. We need to recognize that most websites are comprised of more than one HTML page, and sometimes we'll want to apply the same style sheet to all or many of these pages. When this occurs, the in-file block method is weak because it allows us to style only one page at a time. We would have to copy large blocks of CSS into the headers of all of our pages. When we'd like to write a style sheet that will be used for multiple HTML pages, it's generally a good idea to put that style sheet in a separate .css file. This is, of course, the separate file method of CSS insertion. If you look above the style tag on this page, you'll see a link element. This link element contains 3 values. We've informed the browser that we're linking to a style sheet. We've told it the type of style sheet. And here, this href value tells the browser where to find the style sheet. I've simply told it to look for 3ways.css, which I know is in the same folder as my 3ways.html web page, which is the page we're looking at right now. If your style sheets are in a separate folder from your HTML pages, you're generally going to have to provide that path. Let's open up that style sheet right now. So right now our external CSS file is empty. After all I did to create it was generate a new text file and rename the extension from .txt to .css. There's no special syntax associated with external CSS files. All we need to do is start writing CSS code, and any HTML page that links to it will automatically pull from the file. The question we should be asking ourselves, though, is how does a web browser determine whether to give priority to the rules in our external CSS or in the in-file block CSS? To explore this, of course, we're going to pit these two sections of CSS against each other. Previously, in our in-file block, we declared the rule all paragraph elements have red text. Now we're going to declare in our external file that all paragraph elements are sporting blue text. And let's see what happens. Even after refreshing our page, we still see the red text described in our in-file block rule, not the blue text described by our external file CSS. This is the behavior we would expect to see if both paragraph rules were defined in the same location, with the red paragraph rule defined after the blue paragraph rule. Because both rules are equally specific, we know that CSS will give priority to the rule defined later. That's essentially what's happening here. When the web browser interprets our web page, it goes through the CSS and external files before the CSS in file, making the external file CSS code that is essentially placed before our in-file code. If this is all there is to it, we would expect that the blue rule would become stronger than the red rule if it had a more specific selector. So let's use the class selector now, and of course apply it to one of our paragraph elements, and take a look. Just as we expected, the separate file text is now blue rather than red, because we used a class selector to define its text color rather than the more general single element type selector, which was used to describe the red text. Now that we're familiar with the interaction between separate file CSS and in-file block CSS, it's time to take a look at inline CSS. Inline CSS is a technique in which we insert CSS directly into the opening tag of an element. We do this by giving the element the style attribute. And between these quotation marks, we can write normal CSS. For example, here I've made it so that this paragraph is both green and boldface font. What we achieve with inline CSS can generally be achieved through ID selectors. For this reason, it's sometimes seen as extraneous and cluttering. It's very important to realize that inline CSS takes priority over all other CSS rules, with one distinct exception that I'm about to show you. But first, let's make sure that our inline CSS rule worked and take a look at our page again. Fantastic. The paragraph element that we've just styled looks as expected, green with boldface font. We've learned a lot in this video about how the CSS cascade operates, what styling attributes manifest when they come into conflict with the attributes of other rules. Before we go, I'd like to show you a way to circumvent the cascade to some degree. That's the important flag. If we flag a rule as important, it now takes priority over all other rules, even inline CSS, if these rules are not also flagged important. If two rules flagged important come into conflict, the normal rules of resolution apply. So now, by flagging that general, least specific rule important, it applies in all instances. After viewing this video, I hope that you're comfortable adding CSS to your pages using the separate file, in-file block, and inline systems. I also hope that you've gained some understanding into how web pages determine which CSS attributes take priority when these systems are used in synchrony. This video will be a surface-level introduction to CSS3. As you probably know, CSS is in a transitionary period of its life cycle. CSS2, which we've been using for many years, is being phased out for the new version, CSS3. Because web browsers have to implement their handling of a new CSS version, it would be very difficult for them if we switched from CSS2 to CSS3 in one go. So, the World Wide Web Consortium, or W3C, is releasing CSS3 in a series of modules, small sections of the whole that will be adopted as the web browser CSS standard one at a time. I'm at their CSS website right now. It's w3.org/style/css/current-work. You'll want to keep an eye on this site if you're doing a lot of CSS development, because these are the folks who are deciding what CSS3 is going to look like. This page has a list of current specifications. A small handful of CSS3 modules have been added to their recommended list. CSS colors, namespaces, and selectors level 3 are all recommended, and this means that they're supported by all major web browsers right now. Most of the modules have this WD, or working draft designation, and that means that they haven't been officially added to the list of CSS features that a web browser must support to stay relevant. However, that doesn't mean that web browsers have not already implemented these features to some degree. And what we're going to be doing in this video is accessing one of these features that technically don't have to exist yet. Here's an extremely simple HTML page. It has a header and a div, which I've given an ID. In my external CSS, I've defined a rule for the ID. It has a width and a height, and I've colored it blue. Here's what the page looks like. One of the CSS3 modules which has not yet been added to the recommended list is the transform module. Using this module, we can do something that we would not have been able to do with CSS2, and that's rotate this div element. The syntax to do that looks like this. Transform, rotate, and then in parentheses the number of degrees. Let's rotate it 45 degrees. Save that, go back to the web page, and hit refresh. Unfortunately, nothing happens. I've done my research, and I know that Internet Explorer 9, Safari, Google Chrome, which I'm using right now, Opera, and Firefox, all of the major desktop web browsers, have implemented this transform rotate functionality. What these web browsers haven't done is committed to me that their implementation is just right and is not going to change the way it operates. They won't do that until W3C declares that these functionalities are added to the recommended list. So, in order to access these functionalities, I have to do a little bit of special syntax. In some ways, this is me as a developer signing an implicit contract that I understand I'm using experimental material, and I won't blame the web browser too much if something goes wrong in the future. That being said, these implementations tend to be fairly stable, and I feel confident using the transform rotate in this instance. The syntax to access the not yet recommended CSS3 options in each web browser looks very similar. To make this work in Internet Explorer 9, I'm going to preface my function with -ms-. For Safari and Chrome, I preface it with -webkit-, and so on and so on. Opera is just an O, and Firefox gets MOZ. I want to be careful to leave my initial function without any preface there, so that when the web browsers do transition to the recommended version of this functionality, it will continue to work, and they will access the fully implemented, in theory, 100% version of the function. So let's save this page. And there we go. We've rotated our div element to cover up the title of the page, but that's not the point. This is something that we could not do using CSS2. There's a lot of really exciting features coming out with CSS3, and we can access many of them in this manner already. Some of the really visually thrilling options with CSS3 are custom fonts, automated rounded borders, and rudimentary animations. These are things that CSS developers have been asking for years. They're going to take previously time-consuming or just not worth the effort processes and make them accessible to really anyone who understands basic CSS. Even if you're developing for an environment where it wouldn't be appropriate for you to use the not yet recommended modules, I highly recommend you play around and familiarize yourself with the CSS3 options as you're exposed to them. Eventually, these modules will become recommended, and already using these modules, web developers are making more visually appealing and exciting websites. If you're feeling adventurous right now, try playing around with Transform Skew and Transform Scale. Until next time. In this video, we'll be exploring the options available to us when styling text with CSS. In order to do this, we'll be styling two HTML pages. The first presents a user with a poem, and the second, in a very similar manner, presents a short story. We'll be writing all of our CSS in an external file so that we don't have to write twice the rules that we're going to use for both the poem and short story pages. Let's begin by taking a look at the poetry page in a web browser. It's a very simple page. It has a header element, some paragraph elements, and also a link to our story page, which is set up in the same manner. The glaring issue is that all of our poem's text has been compressed into this great big block, which is not human readable, especially for a poem. If we go back to our HTML page, we'll see that the poem is presented in a much more human readable manner. And it's kind of odd that we would lose this readability when we went from HTML to browser display. The issue is a CSS styling property called whitespace. An element's whitespace property is responsible for two related things. First, it describes how the text will handle the presence of space, tabs, and new lines, what we call whitespace. And secondly, it describes how the text will react if the space given to it, generally the size of the containing element, becomes too small for it to render full lines naturally. To begin playing with the whitespace attribute, let's create a class for our poem paragraph. If we wanted to, we could explicitly write the default whitespace rule which our paragraph is observing like this: whitespace normal. The normal whitespace rule, like all whitespace rule, declares two things. First, it declares that all whitespace collapses into a single space. And secondly, it declares that text will wrap. Let's start with the collapsing bit of the rule. That's what's bothering us with the display of this poem. all white space collapses into a single space means that we'll never see new lines. We will only ever see lengths of the white space the length of a standard spacebar space. We need new lines to make our poem display like a poem should. Wrapping means that the text will add new lines when it comes to the end of its containing element. We can see this by shrinking the size of our window, thus compressing the width of the paragraph element which contains the text. The text adds new lines at the end of words so that it still displays properly in the width that we've given it. In addition to the inherit option, which just says use the white space attribute of my closest relevant ancestor, we have 5 options. Instead of normal, we could choose no wrap. No wrap works just like normal, but no wrapping occurs. That means that when we resized our browser window, rather than adding new lines to attempt to make the text fit, our browser would simply display whatever bit of the text fit in our new frame of view. This is not what we want because we're very interested in getting rid of the collapsing whitespace property, which no wrap preserves. To get rid of collapsing whitespace, we could choose the or preserve option. This means that whitespace is preserved as it is in the raw text. All by itself also means that no wrapping will occur. If we'd like to both preserve whitespace and have some wrapping, we could choose either pre-line or pre-wrap. Pre-wrap means that whitespace is both preserved and normal wrapping occurs, whereas pre-line is kind of a middle child. It actually says that whitespace collapses, but whitespace will not collapse across new lines. Also, normal wrapping occurs. For our purposes, both pre-line, and pre-wrap will look pretty good. They'll get rid of that blocky text view that we didn't like. I'm going to choose the pre option because I do not want the browser to ever decide to break the lines of a poem. While we're at it, we can make our poem look a little more poem-like by adding text align styling. By default, text is aligned to the left, or the left option. In this text editor, the text is aligned to the left. Text can also be aligned to the right, which is just the flip of this. The text will be flush to the right side of the screen, or in this case, the element containing it. We're going to use the text align center property, which means the center of every line of text will be in the center of the element containing it. So let's save that, go back and save our poem page, and take a look at that in our browser. I think that looks much better. It looks like a poem. Let's leave off the heavy lifting for a minute and do some aesthetic level styling. I'd like to underline all of these H1 elements to separate them from the rest of the page. I'm not going to need a class designation for this because this is a change I'd like to make across all H1 elements. But I'd also like to do some custom styling for all story and poem titles. And for that I will need a class because I need to differentiate them from other paragraph elements. So we'll make that the title class. And then I'd like to do some styling for authors. I'm of course going to need to make these class designations on the story page as well. So like I said, we can access the H1 elements through a general rule. And what we want to do here is underline these elements. As far as CSS is concerned, underline is a text decoration. And it's called underline. My other text decoration options are overline, which is a line that appears over the text, and line through, which is a line that appears through the text. It's actually line dash through. Now, let's make all of our titles bold-faced text. And we do that with the font weight option. And we can simply choose bold. Similarly, we can make author elements italic text by changing the font style option to italic. So let's save everything and take a look at our page in browser and make sure that these changes occurred, which they did. There's our underlined, bold, and italic text. If we go to the story page, we do see underline, bold, and italic text. At some point, we should probably modify the white space removal on the story block like we did with the poem. But for now, I'd like to modify the hyperlink. Because hyperlinks have a couple of states, like mouse over and clicked, we can do some interesting things with them. Here's our page's link element. It's actually an anchor element with a special attribute that makes it a link. We could then style this element by writing a general rule for anchor elements, but that's broader than what we want to do. We'd only like to select anchor elements which happen to be links. And we can use the link pseudo selector to do that. What the link pseudo selector does is selects all of an element type, in this case anchor elements, which happen to be links, and that's exactly what we want. My plan is to make the links on our page invisible to casual viewers. I'm going to do this by turning all of the links white, where they'll blend in with the white background of the page. Unfortunately, this rule alone won't achieve that in all cases. That's because there's two types of links. Unvisited links, which we've styled here, and visited links, which get their own styling rule. On a web page, you generally see visited links as purple and underlined, and unvisited links presented blue and underlined. To style our visited links also, we use the visited property. I've tabbed in this second rule because it's conceptually linked with the first. The tab has no effect on the execution of my code, but makes it easier for me and other developers to see that this is a block of related rules. If we go to our web page now, we'll see that the link element has disappeared. I can, however, mouse over the element and click on it. It still exists. It's just white, and I can't visually discern it from the background. I think it would be fair for our links to visually identify themselves when a user mouses over them. We can do this with the hover pseudo selector, which of course applies when a user has moused over the link. Let's use the general blue color for links that the user has moused over. You should only ever declare a hover pseudo selector after you have already declared the link and visited pseudo selector for that type of object. The last pseudo selector I'd like to use here is the active pseudo selector, which applies when a user has actually clicked on the link. It's a really good idea to declare this selector because it provides immediate visual feedback to the user that their action has been received. Like the hover pseudo selector, you should only ever declare an active pseudo selector when the link, visited, and hover pseudo selectors for that element type have already been declared. Let's take a look at our page and make sure that our link worked as expected. It's still invisible. When we mouse over it, it turns blue, and when we click it, it turns green. I think it's about time we style our story element. So let's create a class for that. As with our poem, we want to modify the way that white space is handled. If you remember, with the poem, we chose the pre or preserve white space option because we wanted white space to be preserved, but we did not want wrapping to occur. For our story, I'm going to choose pre-wrap because I do want wrapping to occur. I'm not going to pick pre-line because that would get rid of any tabs that the author has added to their story. The other thing I'd like to do here is change the font that our story is presented in. In CSS2, we do this with the font family property. Ideally, I'd like my story to present in Arial font. The important thing to understand about fonts when it comes to CSS2 is that a browser can only display fonts that are loaded on the machine it's running on. That means that even though Arial is a web-safe font and it should be loaded on any machine viewing web pages, I can't be guaranteed it is. So I can specify backup fonts by separating the fonts with commas. In this case, I'm going to specify sans serif as a backup font. This isn't actually a font, it's a family of fonts. And machines who have fonts installed know this. So if the machine does not have the Arial font installed, it will pick any font from the sans serif family to substitute. Fonts that come earlier in the comma separated list will take precedence. I should also note that if the font has spaces in the name, it needs to be included in quotation marks. Before we'll see these changes on our page, we of course need to specify that this paragraph element is of the story class. And here's our modified story page. The font has changed to Arial, and we can quickly check that wrapping is working as intended by resizing the page, and wrapping appears to be working. The last thing I'd like to do is modify the font that our poem appears in, but I don't want to use a web-safe font. I have a very specific font in mind. The technique I'm about to show you is generally considered a new CSS3 technique, but in reality it's been supported to some degree since CSS2. However, it's not until recently, when all major browsers began upgrading for CSS3, that we could make the claim that this technique is supported by all major browsers. Let's take a look at my desktop where I'm serving this web page from. In addition to my HTML and CSS files, I have two font files. One is a .ttf, or true type font, and the other is an embedded open type font. This is the same font in two files, and the reason I need two files is that Internet Explorer and all other web browsers view fonts differently. Internet Explorer, we will serve the .eot file, and we'll serve the .ttf file to all other browsers. You may see fonts in the .otf format as well. For our purposes, we can use that format interchangeably with the .ttf format. If you find that you have a .ttf or a .eot and you'd like to create a copy of that font in a different format, there are many free online converters available. So let's go ahead and instruct any visiting web browsers to dynamically load a new font from those two font files that we just looked at. We do this with CSS's font face rule, which essentially allows us to declare a brand new font type. The font face function takes two parameters. First, we give it a font family, and this is the name of our new font. Let's call it custom. And second, we need to tell it where to find this font. We know that our font files are in the same folder as our CSS, so we don't need to path to them. We can just serve up the URL myfont.ttf. This will work for all major web browsers except for Internet Explorer, because if you remember, Internet Explorer does not use .ttf files for its font, it uses .eot files. Now we've supported Internet Explorer. We don't need to specifically target the different web browsers with these rules, because if a rule does not apply to the web browser, it will simply skip over it. Now, all we need to do is use the font family attribute in our poem rule to access the font that we've dynamically loaded. And here's our poem in its creepy but appropriate font. Having come to the end of this video, it's my hope that you've gained an understanding of the concepts of whitespace preservation, wrapping, that you can style links in various states, that you can create bold, italic, and underlined fonts, and that you understand how fonts as a whole are handled by the web browser and the CSS. Until next time. In this video, we'll explore the basic options available to us when styling tables and lists in CSS. We'll be modifying this page, which is a single table containing 4 lists and, of course, some basic text. We're going to make the table more aesthetically pleasing, and we'll be modifying each of the list elements so that they all use some slightly different settings. Let's start by styling the table. I've already given it a unique ID. And I think the first thing I'd like to do is add a border to our table, because right now the elements it contains appear to just be floating in white space. We do this with the table's border option. And input for this option can look a couple different ways, but generally you'll see and use it like this. Our first input element is the width of our border. And to create a pretty understated border, let's just stick with the 1 pixel width. Next, we're going to specify the visual style of the border. There's a lot of options here. We could choose dash or double to have a double line, but let's just choose the solid option, which will give us a plain old simple border of a solid color. And lastly, of course, we need to define what color that will be. So let's just choose black to start off with. If we take a look at our web page, we'll see that our borders appeared around the table in its entirety, but the table's individual nodes are still not divided from each other. To get borders that divide the table's cells from each other, we're going to have to style more specifically. Let's use descendant selection to access both the table's header cells and the table's normal cells. We'd like all the borders in our table to look the same, so let's copy and paste the border code we wrote for the general table into each of our new rules. That's going to give us a table that looks like this. And while we've divided up the cells successfully, we now have a double border where we'd expected only a single solid line. That's because each cell is drawing its own border, regardless of if a border from another cell or the table as a whole already exists on that side. There's an easy fix for this that we can do at the table level. Let's use the border collapse option and change it from its default to collapse. This says that whenever 2 borders would normally be drawn in the same place, we just like our table to draw 1. And we get the table border that we expected and originally defined. Before we add color to our table, I'd like to play a little bit with these bottom cells. The words Roman numerals and image marker are coming closer to the line than I think looks good. It makes it a little difficult to read and it looks scrunched. We can modify this rule so that the table's standard cells automatically resize themselves, such that no object they contain is ever allowed to come within a certain distance of their borders. We do this with the padding option, and let's choose 5 pixels as our mandatory degree of separation. Before we head back to our browser, let's also add some color to the table. Notice that our general table rule is less specific than the rules for our header cells and general cells. That means that whatever we declare for our general table rule is simply going to act as a default until we update the value in either of these rules. So let's set a default background color to a light green. And then in this rule, which ends up defining the table's header cells, let's change the background color to a darker green. While we're at it, let's also change the color of text within these cells to white. And on that note, we can change all of our table borders to white as well. This will help the table blend into the white page, while still maintaining dividers between the table cells. In addition to the new colors, which are rather hard to miss, notice also that the columns of the table have resized to accommodate the padding rule we declared. That's all the styling we're going to do in tables for this video, but we are going to style the 4 lists that this table contains. The first list style rule we're going to deal with is called list style position. What it does is it declares whether or not the markers of the list count as physical objects in terms of the list positioning and wrapping in interaction with all other elements. List markers declared to be outside don't have any physical interaction with anything. The default is position outside. So in this sense, our lists on the bottom of our table are just dandy because they're on our position outside row. But we do need to change the position rule of our top 2 lists. So let's start by doing that now. To save you from having to slog through any HTML with me, I've gone ahead and assigned unique IDs to all of the lists in our table. The ones on top are ordered list 1 and unordered list 1. These are the ones whose list style position we'd like to change. So let's go ahead and change list style position for these guys to inside, moving their markers from non-physical elements, which just float to the left of the contents of the list, to physical elements that now must be wrapped and positioned around by everything else. If we make that change and go back, we'll see that our list moved to the right because now our markers are centered within the cells rather than the text that came to the right of them. It looks like the other thing we're supposed to do with our list is change what kind of markers they use. Let's start with the ordered lists. For our top ordered list, it looks like we're supposed to change our markers from these standard numbers 1, 2, the decimal option, to alphabetical values, so A, B. For our bottom ordered list, we're going to change from decimal numbers to Roman numerals. To change the style of a list's markers to one of the many essentially preloaded options, we use list style type. For ordered lists, the default is decimal. And for unordered lists, the default is disk, that filled in round circle. For our first ordered list, we'd like to change from decimal to an alpha value. Our options for alpha values are either upper alpha or lower alpha. Let's go with upper alpha here, which is alphabetical characters in the uppercase, starting with A and going to Z. We also need to style our second ordered list with Roman numerals. So let's make that list style type upper Roman. Just like with alpha values, we could also use lowercase Roman numerals instead. So let's save that and take a quick look, make sure everything worked as expected. And it did. Our final step is to create no marker for the top unordered list and to use a custom image as the marker for the bottom unordered list. So we already have a rule for the top unordered list. And I'm just going to copy list style type and change it to none for no marker. Lastly, we're going to need a rule for unordered list too. And to use a custom image, we do not use the list style type option. We use list style image. And let's provide the image via a URL. And I've called it marker.png. If we save that, we should see all of our final stylized markers. At the end of this video, you should have a lot of options available to you when styling tables and lists in CSS. I should also mention that everything we did in this video was CSS2. None of it was CSS3 specific. I would encourage you to explore some of the attributes where we didn't go over every possible option. List style type, for example, has many, many options besides alpha, Roman, none, decimal, and our unique image. And a lot of styling options can open up for you if you're aware of all of them. In this video, we're going to learn about how CSS handles background images. Let's start off very simply. Let's make our first goal to add this image to a web page as its background. To modify a page's background, we need to be working with its body element. We could do something like this if we just wanted to change the page's background color. But right now, we'd like to assign an image to the page's background. All of my background images I've put in a folder called Images that's located in the same directory that my CSS and HTML files are. So the path looks like this, to full_background, which is the image file that we were just looking at. So let's save that and take a look at our web page. Great, our page has a background, which appears behind all the other elements of the page as we would expect. You may have noticed that the actual background image is larger than our browser window can display at any one point in time. While this looks pretty decent because our background is an abstract image, it could look kind of odd if we had a more structured scene. We can dynamically resize a background image using the background size property. You might notice that my text editor doesn't color background size the same way that it normally colors the attributes of a CSS rule. That's because background size is a CSS3 level rule, and it probably hasn't been added to the library of the syntax highlighter. That should set up some alarm bells in our brains. We should look and see which browsers support background size and in what functionality. I've done the research, and I know that all major browsers support background size in some level. It's on the general text of all major browsers except for Mozilla Firefox. So all we need to do to use the rule is write it normally and then create an identical rule with the -moz- header for Firefox. Background size takes two parameters, a width for our new background and a height for our new background. We can give these parameters in three ways. We can simply say auto, and then the browser will use the default value. So if we did this, we would expect nothing to change on our web page. Instead of doing that, we could present pixel width and height to the web browser. 1280 pixels by 782 pixels happen to be the width and height of our background image already. So if we did this, we would also expect nothing to change. Width-wise, we'd like our background to stretch the entirety of the screen. And for that, we can use a percentage value. This isn't actually 100% of the screen width. It's 100% of the width of the background's containing element, which is the body element. Fortunately, for our purposes, the body element will stretch all the way across the screen. The body element will not stretch all the way across the screen vertically. So, if we did this, our background would look very odd. The background will only be sized to the height of our body element, which will be only as large as the header 1 element it contains. So our background looks like this. It gets shrunk and then repeated vertically, which is certainly not what we were trying to do. So let's cut our losses there and allow the background to use its automatic height as a Y value. So it will be as stretched as wide as the web page we're viewing, and then 782 pixels tall. Looks like this. That's all we're going to do with our simple background. What I'd like to do now is set up a scene using the two background images remaining in our image folder. This gradient background, which will stretch across the top of a screen to make a fade to black effect, and this partial background, which is the image of a tree, which we're going to put in the bottom right-hand corner of the screen. It should look pretty neat. To refresh your memory, here are the background images we're going to be using. We've called this one partial_BKG, and our goal is to put it in the bottom right-hand corner of the page. We'd like it to always be visible no matter how the page is resized or scrolled. This is our second background image. We've called it the gradient background image. It's only a couple pixels wide, but when it's repeated across the x-axis, it will make an interesting fade from white to black effect on our web page. Let's start by getting rid of this old styling. We're not going to use it. And now we're going to tread on CSS3 territory again. CSS3 allows us to declare multiple background images for a single element, in this case our body element. We do this by comma separating the loading. So let's start by loading our partial background, that's the tree. And then second, we'll load the gradient background. Whichever background image we load first will appear in front of the other background image. Let's take a look at what we've done so far. This is a good start. We can see both of our background images, but we don't want our gradient image repeating vertically, and we don't want our tree or partial image repeating at all. We'd like our partial image pretty much right where this tree in the bottom right-hand corner is. We just like it in isolation. Let's handle the repeating first. We can access this attribute of background images using background repeat. And we have a couple of options here. For our partial image, we don't want it to repeat at all. So let's choose the No Repeat option. To style our second image, we simply choose a different option separated by a comma. We'd like our gradient to repeat only across the x-axis, so we choose Repeat X. If we only wanted it to repeat vertically, we would choose Repeat Y. And here's that in action. That's what we want for our gradient. It stretches across the page and it will only ever appear at the top. Now we just need to move the partial image to the bottom right. We can change where a background image displays by changing the background position option. Just like with the background size option that we were using earlier, we're going to specify x coordinate and y coordinate values. We can do this in terms of pixels, or in terms of percentages, or in terms of preset values, which we're going to use right now. Let's change the positioning of our first background image, the partial image, that tree, to be right bottom. And let's change the positioning of the gradient background image. Well, let's not change it. Let's keep it with its default, which is left top. In addition to the right, bottom, left, and top keywords, we can also always use the keyword center to center the background image across that axis. This background position rule all by itself is not going to give us quite what we want. That's because we're still styling this partial background image in terms of the body element, which does not necessarily extend all the way down the page. I guess the question we should ask ourselves here is, instead of styling our backgrounds in terms of this element that contains them, can we style them in terms of the actual browser window? And position-wise, the answer is yes. We can use the background attachment option to change our attachment from its default, which is relative, as in relative to the object that contains the backgrounds, to fixed, where they will be styled position-wise in terms of the browser window. Let's take a look at that. So here's our newly styled background page, which is pretty neat. And if we resize the browser window, that tree will always be in the bottom right of the window. The great thing about backgrounds is that they visually connect different pages, so that the user doesn't feel like he's jumping from web page to web page so much as navigating your website. At the end of this video, you should be very comfortable with backgrounds. The techniques we've gone over should serve your background needs 9 times out of 10. In this video, we're going to be styling a button using pre-rendered images. In order to do this, we're going to have to utilize what I would call an advanced CSS maneuver, the sliding doors technique. A common frustration when adding images to HTML elements in CSS is that when the HTML elements resize, we'd like the images to resize along with them. With the advent of CSS3, sometimes we can just stretch or compress our images to the new HTML element's width or height. But oftentimes stretched or compressed images don't look quite as intended. In these instances, the sliding door technique can often be just what we need. The sliding doors technique takes 2 or more images and attempts to display them so that they appear to be one image of any size. In this video, we'll use the sliding doors technique and 2 images to create a button that can be almost any width. In reality, no button we create with this technique can be wider than the first image we use. But if we think that we're going to need very wide buttons, all we need to do is extend this image to the right. Our first image comprises 2 of the 3 parts of a button. It has the left cap of the button and then the center section of the button. Our second image is only going to be that third part, the right cap of the button. The center section of this button is wider than we will need it to be for most of our elements. And that's by design. Because when we insert the right cap onto this first image, let's say we put it right here, we'll cut off the display of all the rest of this image afterwards. Thus, the right cap slides onto the image and locks it to a certain size, there being the sliding door metaphor. So let's go to some code. There's only one HTML change we need to make to this anchor element to allow us to perform the sliding doors technique on it. Right now, the only way for us to display both the left and right-hand sides of our button would be to assign them both to this anchor element as background images. That would let us display both images, but we wouldn't be able to perform the cutoff of the left-hand image at the desired width. At best, that image would still display under the transparent parts of our right end cap. We're going to circumvent this issue by placing a span tag within the anchor element. This span tag will be home of most of the button image, the left-hand side, and the anchor element itself will house the right end cap. We'll achieve the cutoff effect by abusing the fact that logically this span element cannot be larger than the anchor element which contains it. We're going to be styling two different elements. We're going to style the anchor element with the button class. We're also going to need to write some styling for the span that it contains. If you remember, the anchor element is going to be where we place the right end cap, and the span is going to have most of the visible button, the left end cap along with that middle section. So let's add the right end cap to our anchor using background image. And here's the path I have to my images. While we're at it, as a precaution, we should probably change the background color to be transparent. That's because by using a colored image file, we've essentially already declared a fixed color for this button. And we don't want any background colors messing with that and making the button appear as we didn't intend it to. While we're at it, we want to make sure that the background doesn't repeat on us. So within this anchor element goes the right end cap. And as it is right now, that right end cap will be displaying on the left-hand side of the anchor element. We fix this using background position and changing it to top right. Okay, some other things we need to do. Our button is not going to resize vertically. It's only going to resize horizontally. We could certainly employ the sliding doors technique to create vertical resizing as well, but for the purpose of this video, that would get unwieldy pretty quick. So let's give it a mandatory height of 30 pixels, which is the height of the image files that we're using. We also need to be floating this element because otherwise the top and bottom bits of our images will not display outside of the text field. And we want our button to go around the text. And it just kind of makes sense to display a button in block form. Okay, we're going to need to add a background to our span as well. This is the left end cap and the center portion of our button. And while we're at that, we should probably spell button right there. To make our text position properly, let's assign a fixed line height as well. That's the area that our text is allowed to display in. And manually declare block display here. This is good as a start. Let's take a look at it in a web browser. Alright, not so beautiful. Let's zoom in a little bit. I have 3 issues with our current button, and believe it or not, they can all be fixed with padding. On a positive note, the left side of our button is cut off at the end of the text, which is the whole idea behind sliding doors. Now, our right end cap did display properly, but we want it to be over to the right a little bit so that it's capping the left side of the button, not mostly hidden under it. Another problem is that the left side of the button is not visibly displaying down below where our text field is. And the third thing I'd like to do, which is pretty trivial, is to add padding to the left and right hand sides so that the "this is a button" text doesn't push so close to the edges of the button. So let's go do that now. Let's start by fixing the left side of the image. The reason that we're only seeing a portion of the image's left side is that the display area of this span is actually only as high as this line height that we've declared. Our button is 30 pixels high, and so is the image that we're trying to display. So if we pad the span with 5 pixels on top and 5 pixels on the bottom, we should have a 30 pixel vertical display area for our image to draw happily in. And this will do that. When you declare all of your paddings in one line, you're declaring top, then right, then bottom padding, and then left padding. Now, one of our other problems was that the right end cap wasn't actually capping the button. It was just stuck to the right of the left image. We can fix this issue with padding as well. And this time, let's just use padding right. If we increase the display area of this anchor element to the right, then our image should display further to the right because that's where the background is positioned. So let's just increase the display area by 10 pixels via padding. 10 pixels being the width of our right end cap. The only problem with this is that now our text is going to appear pushed to the left of our button. Because text is not rendering within this portion of the button, it's only rendering in the span. However, if we simply add equal padding to the span on the left, we'll be pushing the text away from both directions and it'll appear right in the middle. Well, we're not actually pushing the text, we're just growing the button around it. But let's save that and take a look again. Refresh, and that actually looks like a pretty reasonable button. To make sure that our button actually resizes and resizes properly, let's go to our HTML and change the text from "this is a button" to simply "button." And voila. The last thing we're going to do here very quickly is assign a rudimentary animation to the button when we mouse over it. We do this by accessing its hover property, which applies whenever the mouse is over top of an object. So we're going to have a special hover case for both of these rules. Make sure you assign your hover property to the actual anchor element and not the span for our second rule. And then all we're going to do is display a different image. We could also do something like move the button down 1 pixel so that it appears to move when the mouse touches it, or change its color, anything like that. But it's always a good idea to have your buttons react to user input. And I'm just going to change my image URLs quickly. Okay, these rules should use everything from the non-hover rules and then simply overwrite the background images, these being more specific rules than the non-hover rules. So that should be everything we need to do to have our button create a basic animation. And there we go. Very cool. This is certainly not the only way to create a button using CSS. Really, anything that you style to look attractive and clickable makes a great button. What I do hope you really absorb from this video, though, is the concept behind the sliding doors technique. Even though CSS3 is reducing the number of cases where we need to use kind of second-level techniques like this, the sliding door technique coupled with images means that we can create a resizable object that looks like whatever we want, no matter what the functionality of CSS that we're using happens to be. Thanks for watching. This video will cover sprite sheets in CSS. A sprite sheet is a single image which appears to contain multiple images. For example, this sprite sheet, which we'll be using throughout the course of the video, contains 5 distinct images, 5 browser icons. We call each of these individual images sprites. The idea behind the sprite sheet is that we can get away with using the single image file for 5 different images by rendering only a portion of the sprite sheet when we would normally render one of these images in its entirety. There's 2 advantages to this approach. First, sprite sheets improve the load time of your page because there's some overhead associated with a client running a browser asking the server to send it an image. This is less important than it used to be with modern high-speed internet connections, but in some instances where pages load many unique images, there can be a significant improvement. The other thing sprite sheets do is improve our organization. These browser icons are all related images. So rather than having 5 separate image files to load in our HTML and CSS code and manage, we can always load just this one image and then navigate to the portion of the sprite sheet that we'd like to use. In this video, we're going to use the sprite sheet in front of us to create an HTML image object, of course styled in CSS, which will display a different image based on the nature of the object that contains it. Before we jump into any code, there's one more image worth looking at. This is a completely transparent PNG image that is 110 pixels high and 110 pixels wide. That happens to be the width and height of each individual sprite which comprise our sprite sheet. And here's our HTML code. Let's ignore this image for now and take a look at these 5 divs. Each of them has a unique class identifier, which corresponds to one of the browsers whose icons populate our sprite sheet. Our goal is to write a generic image object, which we can place within any of these divs and will display the appropriate browser icon based on its parent's class. We haven't done any styling for this image yet, but let's go ahead and preemptively declare it to utilize the sprite class. We're also going to give it a source image. We're going to use the sprite placeholder image we were just looking at, that transparent PNG file, which, if you remember, is the width and height of an individual sprite. The reason we're doing this is so that the image object will always have the width and height of the sprite. If we assigned as its source image the actual sprite sheet, its width would be 5 times what we expected, and we'd have to manually style that down, and it could get a little confusing. This is generally seen as the more elegant solution. We'll add the sprite sheet in a purely visual capacity by declaring it to be the background of this image in our CSS. So our image object could be the descendant of one of 5 different classes, leading to us needing 5 different CSS rules to declare which part of the sprite sheet we're going to use for each instance. I copied the CSS rules to my clipboard so that you wouldn't have to sit through me writing all 5 of them. Just as a quick refresher, we're going to be assigning the portions of our sprite sheet to the background of this object. We have a transparent foreground, so we're going to see the background just like it was a normal image, but wrapping and positioning will take into account the foreground image, which is the size of the portion of the sprite sheet that we're going to use. If we put the sprite sheet in the foreground, wrapping and positioning would take into account the entire size of the sprite sheet, and it wouldn't look like we expected. So the first thing we need to do is actually load our sprite sheet, which is in, for me, images sprite sheet. And it's a PNG file as well. Now, that's pretty standard. What we need to do now is navigate that sprite sheet to the image we desire. Think of our transparent image, which is the foreground, as a window. we're only going to be able to see the piece of the sprite sheet that we've placed behind that window. By default, that will be this Internet Explorer icon, because it's the first square of the sprite sheet that the window would by default cover. To refresh your memory, our transparent image, or our window, is 110 pixels wide. So, if we were to shift our sprite sheet 110 pixels to the left, our window would now be covering the Firefox icon. So, if we assign this rule to our Firefox condition, then all we need to do is position our background negative 110 pixels from where it would be, positive numbers shifting the background to the right, negative shifting it to the left, and have no transition on the y-axis. If our sprite sheet was styled vertically, we would of course be shifting on the y-axis and not the x-axis at all. If the sprite sheet had multiple rows and multiple columns, we're going to have to shift across x and y. The next image in our sprite sheet is the Safari image. So our shift for Safari is going to be 110 pixels more than we shifted for Firefox. So let's go ahead and make that negative 220 pixels. After Safari comes Google Chrome, which we've already written some of it for, so that's of course 330 pixel shift, and so on and so forth. Once we have a unique background positioning rule for each class, we simply place this image object between each div, and that alone is sufficient to give them all unique icons. The other thing I've done on this page is used a second sprite sheet to create a page title, which animates when we mouse over it. I achieved this using pretty much the same technique. I just needed a wider placeholder image, and rather than styling based on what class my ancestor was, I simply wrote two different styling rules, one for the standard case and one for the hovered over case, in which I offset the background by 300 pixels, the width of each sprite in the image. At the end of this video, you should be feeling comfortable with sprite sheets, at least on a conceptual level. They can be kind of confusing if you run across them in CSS and HTML code and you're not familiar with the concept. I encourage you to embrace them as organizational tools in your web development. This should be a fun video. Rather than simply styling existing HTML with CSS, we're going to be using both HTML and CSS together to create a brand new user interactive control. Already in our HTML, we've defined three lists: names, colors, and food. Our goal is to collapse these lists and create a banner on the top of the page which simply has names, colors, and food as options. And then, when the user mouses over one of these options, we'll display the list elements. Generally, we call this a drop-down menu. Let's begin by creating the structure of our drop-down menu in HTML. The lists which are going to comprise the content of the menu have already been created for us, so we just need to build a skeletal framework and then drop them in. I'd like to start by creating a div element and giving it a brand new unique ID. Let's call it My Menu. I do this because we're going to have to write a decent amount of CSS to make our menu work as intended. What we'll do is preface all of our CSS rules with the My Menu ID so that they never apply to anything except the menu they're intended for. Now, our drop-down menu essentially has two parts. It has the always visible banner and then the only sometimes visible lists. For the always visible banner, I'd like to use a table with only one row. And then we'll isolate each list to its own table column. In reality, we don't have to use a table for this. We could also use a horizontal list or really just self-styled HTML tags. But the table will work great. Before we drop our names list into one of these columns, I'd like to do one more thing. I'd like to surround the new list with its own div element, just like we did with the menu, and really for the same reasons. We can't give each div element its own unique ID because there's going to be 3 of them though, so we'll have them share the submenu class. Skipping ahead very briefly, I've gone and copied and pasted each of our lists within their submenu divs. Notice that the titles of the lists are not contained within the unordered lists themselves. Let's take a really quick look at this page in our browser. The horizontal and vertical structure is there, but nothing else is. It certainly doesn't look good. And that's our cue to write some CSS. So what makes our drop-down menu unique is that not all of its elements are visible all the time. So for our first rule, let's attempt to turn all of the unordered lists within our submenus invisible. CSS actually has a visibility property, and that might seem like a really good choice here. But we're going to use display instead. That's because if we change the element's visibility, we'd only be changing the visual portion of the element. We wouldn't change how it interacts with other elements on the page, and we don't want it interacting with other elements when it's invisible. If we set its display to none, however, it will neither interact with elements nor appear visible. We don't want our submenus invisible all the time though, so let's create a related rule. And let's have this one apply to the submenus when they're hovered over. In this case, we do want our unordered lists to display. So let's change display to block. If we save that and take a look in the web browser, we're going to see this, which is a really great start. And we can see the unordered lists when we mouse over the corresponding tags. However, there's a positioning issue where when the unordered lists display, they push around the other elements on the page, and we certainly don't want that. Probably the simplest solution available to us is simply to change the position information of our unordered lists to fixed. This will cause them to position regardless of the other elements on the page, over top of them if need be. It will cause some artifacts if the user scrolls while mousing over our menu, but for our purposes here, it's more than sufficient. If we take a look at our page again, we'll see that the unordered lists display without pushing around any of the other elements on our page. Just using these 2 CSS rules, we've created the basic functionality of our drop-down menu. CSS is about more than basic functionality, though. We'd also like our menu to look good. So let's do some visually appealing styling now. Let's start by giving the menu as a whole a background color. This color is a chalky purple that I think will look good. And the other thing I noticed that kind of irked me was that the tags for our submenus were very close together. We can access those tags by accessing the individual columns within our menu. And we can force them to space each other further apart by editing their padding left and padding right. Padding left and padding right is just like editing padding as a whole, but it lets us change it for each up, down, left, and right separately. So let's make our padding left and right 15 pixels for each size. Now, the reason I didn't want to change padding top or padding bottom is that it would push our submenu up or down when the submenu actually pops into existence. Since we've given our menu as a whole a background color, we should probably give one to the submenus too. Let's choose a gray. I think that will look well with purple. And save that and take a look at our menu. Okay, so we see that the padding worked, and our menu stretches across the page with its banner. If we added more columns to the menu, they would stretch along the banner. If we mouse over, our submenus now appear in a gray case. This is good, but coloring everything shows us a couple other things that need to change. First off, our submenus are appearing too far down. We'd like them to appear just underneath their tags. While we're at it, if we put a border around our submenus, I think they'll blend into the menu as a whole a lot better. So let's do that now. Let's add borders to our submenus. We'll make these borders the same color as the general menu and apply it to all sides except for the top, using the same technique we used with our padding. We'll just do border bottom, border left, and border right. This will make the border appear to have pulled down from the menu, as opposed to being a separate floating entity, at least in theory. So let's give it a decent thickness, 3 pixels, a simple solid border, and then there's the color we used for the menu as a whole. We can copy and paste this rule and simply change bottom to left and right. While we're working in these submenus, there's a couple other things I'd like to change. Most importantly, I think, let's change their list style type to none so that they don't have bullets anymore. And let's also give them a padding of 10 pixels so that the edges of our submenu don't come so close to the text. If we save that and take a look in our web browser, well, it's going to look the same until we mouse over anything. There we see our borders like little buckets, but the issue still stands that our drop-down menus are too far below our menu for it to look quite right. Before we can figure out how to move our unordered lists up, we have to figure out what's moving them down. It turns out that unordered lists, like all elements, have a margin around them that offsets them from existing elements when they're created. If we change the width of their top margin to 0 pixels, they'll display right where they're created, regardless of what elements are above them. And there we go. Because we've gotten rid of the margin, we can now scroll down to our unordered list without breaking the hover effect. And this is our fully functional drop-down menu. I hope you enjoyed this video putting some of the things we've learned into practice. There's certainly a lot of things that can be done with this menu, from extending the type of objects it can contain to making it a general reusable control, and of course a lot of visual things to make it prettier. If you're feeling really adventurous, I would suggest attempting to add additional drop-down menus accessed through the elements of the drop-down menus we already have. Thanks for watching. As far as CSS is concerned, every HTML element exists within a multi-layered box. Each of this box's layers has different properties. If you've modified an element's padding, border, margin, or even its width and height, you've modified one of the layers of what we call the box model. In this video, we'll be exploring exactly what these layers represent. That way, our CSS code is always making exactly the modifications we expect it to. The image on the page in front of us is an HTML element. That means that it's subject to the box model, and the manner in which it displays and positions, both in regards to the page as a whole and the elements around it, in this case the text, is affected by 4 of its box model layers. These are the content layer, the padding layer, the border layer, and the margin layer. Additionally, the way it looks to us, but in no way the way it positions, is affected by a 5th layer, the outline layer. We're going to be modifying these layers one by one, starting with the content layer, which is the innermost layer of all HTML elements. The content area, the innermost rectangle of the box model, is where all of our element-specific information goes. Since we're working with an image, a rectangular image, the size of the image we see in our web browser is going to fit to the size of the content area that we've declared. Right now, the content area defaults to encompass the entire image in its default width and height. We modify an element's content area by changing its width and height attributes. It's really important to realize that when we change an element's width and height, we're only modifying the size of its content area. For example, it might seem intuitive to assume that an element whose width and height are both 200 pixels will never affect position-wise elements that are 100 pixels from its center, both vertically and horizontally. This isn't always the case, however, because 200 pixels by 200 pixels is only the width and height of the inner box in its box model. Its padding, border, and margin can all have their own physical space that live outside the area of the content area. For now, let's modify the size of our image to be a little smaller by just setting the width to 200 pixels. If we refresh our web page, we'll see the image shrink to the new size. Notice that because we didn't define a height explicitly, the aspect ratio of the image, the ratio of its width and height as an image file, stays to its default. Let's talk about padding now. We use padding to increase the space an object takes up without actually increasing the size of an object's content area. So, if we were to add 5 pixels of padding to each side of our object, we should displace more text but should not see any larger of an image. You may have noticed that our object has a background color declared. We haven't seen the background color yet because the image takes up the object's entire area. Padding, however, will display an object's background color in its area. So, in addition to displacing more text, we should see 5 pixels of background color outside of our original image. We can declare padding, margin, width, and height in pixels, like we've done here, or also by a percentage. If instead of 5 pixels we were to declare a left padding of 50%, the width of the padding on the left side of our image would be 50% of its containing element's width. In this case, it's contained by the body of the page, so the padding to the left side of our image would be pretty ridiculous. It would be 50% of the page's width. So let's stick with 5 pixels and take a look at that. If we refresh our page, we're expecting to see more text displaced and that 5 pixel pseudo border around our image. And there we go. We saw the text move, and now we can see some of that background color peeking out from around the image where our padding exists. The next level up in our box model is the border. The border is going to affect both the positioning and the display of our object as a whole. That means that visually we're going to see the border, and also adding a border will increase the size of our object as a whole, so it might change the positioning of our object on the page or the positioning of the objects around it. We generally style a border by giving it 3 attributes. We give it a width, we give it a style, let's make this one dashed, you'll see why in a second, and we give it a color. Let's use black. Like padding and margin, we can declare the individual attributes of the border on separate lines or all at once like we did here. And we can also just style one side of the border. So we could be styling just the top border of our element. So let's open up our web browser and take a look at that. When we refresh the page, we should expect to see some text displacement because the border is a positioning element. We should expect to see the same amount of text displacement we saw for the padding, and we should also, of course, expect to visually see our border. And there it is. If you'll look in between the border's dashes, you'll see that our green background color is there. That illustrates pretty clearly that Borders are affected by the background of the element as a whole. The last two levels of our box model, margin and outline, will not be affected by the object's border. Let's start by exploring the margin. Because the margin isn't affected by our object's border, we should expect it to be completely transparent. Otherwise, it's really just like padding that appears outside of the border of the element rather than outside of its content area. Because padding is affected by the object's background, we often use it to change the apparent size of the object, or to make some room to add a border, which then changes the apparent size of the object. Because margin is transparent, we generally use it to create the appearance of space between this object and the other objects around it. So let's go ahead and add a 15 pixel margin to each side of the object. And then jump into our web browser and click refresh. There's some significant text displacement, and we've kind of given our image room to breathe. The last layer of the box model is the outline, and I kind of like to think of it as being on the same layer level-wise as the margin. That's because, like the margin, the outline goes right outside the border. Where the margin is purely a positional element and doesn't have any display properties, the outline is purely a display element and has no positioning properties. No matter how ridiculous an outline we create, it won't affect the positioning of anything on our page, even this element here. To illustrate this, let's add a sizable outline to our element. We declare outlines just like we do borders. So let's make ours 30 pixels because we want it to be wider than our margin for the purpose of this example. And let's have it be a solid red line. In our web browser, so the distance between this text here and our border, that's the area encompassed by our margin. Our outline travels from our border through our margin and even through some of the text surrounding our object. It's able to do that because it's a purely visual element. It has no positioning information, so it doesn't displace the text. If we made our margin 30 pixels, it would have displaced the text in the area colored red by our outline. And those are all the real pieces of the box model. Content surrounded by padding, surrounded by border, which is surrounded both by margin and outline. Exploring the box model really marks a new phase in our development as CSS developers. Rather than focusing on a single object, we're taking our first steps towards looking at our web page as a whole and worrying about and styling for how the elements are going to interact with each other. Thanks for watching. In this short video, we're going to do two main things. First, we're going to explore how HTML images and HTML text elements handle it when we resize their content areas. Most notably, how do these elements handle it when we make their content areas too small for the elements to display comfortably at their default size? The second thing we're going to do is explore the CSS overflow attribute, which will allow us to explicitly define how an element handles a content area which is too small for it. The web page we're going to be styling really contains only two elements, this image and this paragraph element. To keep things moving, I've already assigned ID selectors to our image and text element. I've also done a little bit of preliminary styling, which you may have noticed. I removed explicitly the padding, border, and margin from both elements and gave them a dotted red outline. With no padding, border, or margin, the outline will surround the content area of each element, so we can see exactly where that is. To begin our exploration, let's simply explicitly set widths for our image and text element. Let's set a width of 200 pixels for our image. And rather than using an explicit pixel width for our text box, let's simply make it 20% of its containing element, which is the body of the page. So this should be 20% of the page's width. Both of these elements should have to shrink to accommodate these width changes. What we're intending to demonstrate here is how the height of these elements changes as a result. Back in our web page, we've successfully diminished the width of both elements. The heights of these elements have also changed to accommodate this. The height of our image element has actually lessened. It's shorter than it was before. That's because image elements, by default, will attempt to maintain their aspect ratio when only one of their axes is changed. Because it's much easier for CSS elements to push the content of your page vertically than it is to do horizontally. This is very reliable when we change the width of an image, but not so much when we're changing the height. The height of our text box, on the other hand, has grown so that the text, which cannot resize, can all fit in the text box still by adding new lines. But what happens if we explicitly set heights for these elements as well, so that they can't comfortably resize across the y-axis? Well, let's find out. Let's set the height of our image to be 100 pixels. Now, we could set a percentage height for our text element. But because web pages can so freely resize themselves vertically, our very simple page here would just resize itself until the height percentage of our text element was a reasonable height for our text to display in. So we're going to switch to a pixel width and a pixel height. Since our text element was originally taller than it was wide after we made our width change, if we make it now a 200 pixel by 200 pixel box, the text should not have enough room to display as it has been now. So let's save that and go to the web browser. And here's our refresh. Okay, starting at the top, our image has compressed itself. You'll notice that the picture is stretched out a bit. The 200 pixel width and the 100 pixel height are now both observed by the image itself, the bit of the element in the content area. This is not what our text element did. Our text element did not resize itself. It simply displayed outside of its content area. This is the default behavior of images in text. When an image is placed in a content area that it cannot comfortably resize to given its aspect ratio, it will resize across the X and Y axis independently. When we place text in a content area that the text cannot all display in at its default text size, it will simply display outside of its content area vertically. If we were to make the width of this text area too small for some of the first words in a line to display in their entirety, the text would appear also to the right of our content area where necessary, though we could change the text wrapping in the text properties. What we're going to do now is explore the overflow CSS attribute. With this attribute, we can change the way that our elements handle these two small boxes. We can make text that acts a little more like this image in that it won't display outside of a too small content box, and we can make an image that acts a little more like this text in that it's going to display at its full size no matter what size the content box we give it. So the overflow attribute handles how the bits of the element that do not fit within the content area will display. There are 5 possible values for this attribute. They are scroll, auto, visible, hidden, and of course inherit. Right now, our text is operating as though we had explicitly declared overflow visible, because this is the default for paragraph elements. Any of the element that does not fit within the content area will go ahead and display anyway. We want to make our text not display outside of the content area. So we could use overflow hidden. then our text would simply cut off at that red dash border that we saw. A text box where we can only see some of the text is generally not that useful though. So let's employ one of Overflow's other options. These are either scroll or auto. If we chose the scroll option, we would see vertical and horizontal scroll bars that would let us navigate our text block and see all of it in the small window of its content area. However, our text will only be cut off vertically because of the way that Overflow is handled. So we don't need that horizontal scroll bar. This is where the auto property comes in. Auto will apply scroll bars only where they would be relevant. So let's save that and take a quick look before we do our image styling. Our text, which only overflowed its content area vertically, now has a vertical scroll bar that will allow us to scroll the content area, like its own window, and view the text in its entirety. Now, we want our image to overflow in the manner that our text element used to. We'd like to see all of the full-sized image, even when the content area is too small to normally display it. Our initial reaction is probably just to go overflow visible, which makes a lot of sense. Unfortunately, if we save this and quickly jump into the web browser, we're going to see no change on refresh. That's because our image is perfectly happy simply resizing its width and height to the width and height of the small content area we gave it. It's not actually overflowing the content box at all. There's a fairly simple fix for this though, and I've already implemented it in our HTML. I've surrounded our image with a div and given that div its own ID that we're about to style. If we can't cause the image element to feel cramped within itself, its own content area, we can cause it to feel cramped within its containing element, this scroll box. So let's just copy the width and height of our image to its containing element, which will now be smaller than the image would like to display. Oh, let's also give it our outline information. And jump into the web browser. When we refresh, we see the entire image, even though the content area of that containing box was too small to display it in its entirety. We also notice that the image has overlapped this text here. That's because the overflowed image is not a content box. It's just that HTML element. So it doesn't have the positioning information of a content box that would tell it to stay away from this text, or more accurately, that would tell the text element to move down to stay away from it. The last thing I'd like to show you here is what happens if we change overflow visible to overflow hidden. Rather than having an image that resizes, we'll simply now only see the bit of the image that would display if the content box of our containing element was just a window. And that's really it for our exploration of images and text in two small content areas. Hopefully this video has saved you from some future moments of, wait, why does it look like that? And you should also now be fairly confident in using the CSS overflow attribute. Until next time. In this video, we'll be talking about styling borders and outlines. In CSS2, we style borders and outlines in the same manner. However, we'll also be taking a look at some CSS3 features which are only available for styling borders currently. The page we're going to be modifying contains only a single image, which we've accessed in this CSS class here. To make sure we're all on the same page with border and outline styling, let's go through the very basics and add a border to this image. We always want to make sure that our borders and outlines have a border style or outline style attribute explicitly declared. If there is no border or outline style attribute, they'll generally choose not to display at all. There's a lot of options available for these attributes, and fortunately, they do share all of them in CSS2. I've listed these options in this comment here and divided them up into 3 groups. The first of these groups is the hidden option all alone. If you set your border style to hidden, it won't display at all. Our other groups are solid, dotted, dashed, and double for the first group, and groove, ridge, inset, and outset for the second group. The second group differs from the first in that these styling options will also be changing parts of your border's color to give it a 3-dimensional feel, whereas solid, dotted, dashed, and double will be either rendering pixels of your border's pure color or transparency. So let's go ahead and use the inset option as our border style. The other 2 attributes we want to make sure to declare for a border are its color, which we can simply set to red. No real explanation needed here. And its width. Border width is the area that we give the border to exist in. In terms of outline, we're simply giving it an area to display in, because the presence of an outline will not affect the positioning of this element or any elements surrounding it. Outlines are purely visual elements. So let's go ahead and choose a 5-pixel border width. Save that and quickly take a look at our web page. And there's the border we styled. You'll notice that the top and left-hand sides of the border are a darker color than the right and bottom sides. That's the inset style we chose, attempting to give our border a bit of a 3-dimensional feel. Before we move on to the CSS3 bits, let's quickly cover the shorthand option of border and outline styling. Rather than declaring border style, border color, and border width on separate lines, we could create this same border by simply declaring a 5-pixel width, inset style, and red color on one line using just the border shorthand attribute. Just for borders, we can also style individual sides separately. If I begin my attribute rule with border top, rather than simply border, I'll just be styling the top bit of the border. Additionally, you could see something like this. Here, I'm styling each side of the border with a separate styling rule in the same line. The first is for the top of my border, the second is for the right, the third is for the bottom, and the last is on the left. CSS3 offers us another really cool option when styling borders. We can use the border radius attribute to create borders with rounded corners. We wanted to do this a lot in CSS2, but creating rounded elements was very difficult. Often it would require external images. With the border radius property, we can create rounded borders using just CSS. I should mention that this only works for borders. It's not an outline styling option. Since it's a CSS3 feature, we need to be conscious of what browsers support border radius in its entirety. The current iterations of all major web browsers support border radius. However, Internet Explorer 8, which is still decently widely used, will not show border radii. Also, it's a good idea to create an identical rule with the -moz header. Even though the current version of Firefox supports border radius all by itself, it's easy to create this identical rule, and it will cause us to support some older versions of Firefox. To create a border radius, we simply supply a radius. And there we go. Now our borders will deform 15 pixels from each corner to create the rounding effect. Let's save that and take a look. Very cool. We've created a rounded border around our image. As with the individual sides of our border, we can use border radius to style only an individual corner of the border. If we just wanted to round the top left-hand side of our image, we would access it with border-top-left-top. radius. I'd like to show you one more CSS3 property in this video. This is the border image attribute. Using border image, we can take an image file and turn it into a border that we can place around any element. Let's begin by checking out the image itself. So here's our image. It's important that it already look like a border, because what we're going to do is divide this image into 9 parts. 4 of these parts are going to be the 4 corners of our border. In our case, these green squares. 4 of these parts are going to be the areas between the corner. And these areas will either repeat or stretch to fill whatever space we give them. Our last part is this checkered bit in the middle, where the content area, the area within the border, will go. The important thing for us to know about this image right now is that the distance from any side to our content area is 26 pixels. So let's jump into the code. Let's get rid of our border radius, because that would confuse it, and start our border image rule. Now, because this is a CSS3 attribute, we need to discuss to what level is it supported. Internet Explorer does not currently support border image, but all of the other major web browsers support border image to some degree. However, we're going to have to write some identical rules using the -moz, -webkit, and -o headers. Chrome currently has border image in its general text, so we're only using the WebKit to access Safari right now. That being said, none of the major web browsers' implementation of border image matches perfectly with the W3 documentation of how it's supposed to work exactly. So make sure you're checking your border images in all major web browsers before you put anything really important online. Now, the first thing we need to do to write a border image rule is to tell it where to find the image that we're going to be using. So my image is called imageborder.png, and it's in the same file. And once we've told our border image where to find the image, we need to instruct it how to cut up our image to create those 9 sections we just talked about. It's going to cut the image using 4 cuts. It's going to make a top cut, a certain distance from the top of the image, right here. Then it's going to make a right cut, a certain distance from the right of the image, a bottom cut, a certain distance from the bottom of the image, and a left cut. We declare these distances one after another, separated by spaces. In our case, we could declare 26 pixels, 26 pixels, 26 pixels, 26 pixels. Or we could do what we're going to do and use a slight shortcut where we declare the top and bottom distances together, and then the left and right distances together. Now, you might have noticed I didn't actually put the px for pixel units after our images. For whatever reason, border image will not work if we put the pixel units. I believe this is because it's designed to support vector images as well as standard images which use pixels. We can also declare these distances in percentages of the entire image's width or height. Then the last thing we need to do is instruct border image how we would like the space between our corners to display itself. We can choose either repeat, which we'll start with, or stretch. Having chosen repeat, we expect the area between the corner of our images to repeat itself to fill the entire area. There's a specified option that's not actually implemented in any of the browsers currently called round. This option, when it is implemented, will cause this area to repeat, but never so much that it appears only partially. So we would never see, let's say, half of this yellow square covered by one of the corners of the image. To achieve this, the area between the corners will repeat as much as it can and then stretch the rest of the way. But let's take a look at the border image we've created in our web browser. And there we go. You'll notice that the individual squares which made up our border image are pretty tiny. That's because the image has had to be scaled down to fit the 5-pixel border width that we specified earlier in our styling. If we were to make the border width bigger, we would see the little squares in their original resolution. Having finished this video, you should have quite a few tools at your disposal to style borders especially, and also outlines, which are styled just like borders in CSS2. Thanks for watching. This video will discuss some elements of margins and padding in detail. We'll go over some techniques, take a look at a few quirks, and see when to use one over the other. The page that we're going to be working with currently contains 5 images. This box at the bottom is actually 2 images next to each other. The intention when creating this page was for the middle pair of images to be styled the same as the box on the bottom. But as you can see, there's a space between them. If we take a look at our CSS, we'll see that there's only a single class rule selected. It explicitly declares that anything with this class will have no padding, no margin, and no border. And this class applies to the 4 images which make up our middle and bottom pair of images. Otherwise, there's no CSS active on this page. I should also mention that that class is extraneous and for point of argument. If we got rid of it, the page would display just the way it is right now. This is not technically then a margin or padding issue. The reason that we see a space in between the middle pair of images is actually because there's a new line between the first image's HTML and the second image's. The bottom pair of images does not have a new line between them because the first image's HTML ends right here and then transitions immediately into the next image. So if we put all of our HTML in one line, we should see our web page change to match that. Okay, excellent. These 2 images now display flush with each other as we intended. I wanted to show you that quick because while it's not technically a padding or margin issue, it's a really easy mistake and an even easier mistake to overlook that is often initially attributed to a padding or margin issue, when the actual root cause is much simpler. Now let's style this top bit of our page so that it looks like the middle and bottom bits. We could of course just add another line of HTML to add another image next to this one like the middle and bottom parts are created, but let's see if we can do it just in CSS. I've set up an ID selection rule for that top image all by itself. It is split image. We're going to need to load that second image file, the one that is the left side of the image. So let's load it as this element's background. Here's my path to the image. Okay, but this alone of course isn't sufficient because our background image is just going to display underneath the current left side image. We'd like it to display to the right of that image. We can add some area for our background image to display in by increasing the padding of our element, which will not increase as a result the content area where the left side of our image is displayed. So if we were to add 50 pixels of padding to the right of our element, we would have enough room for our background image to display happily, and the left side image would stay right where it was. To make this rule a bit more general, we should probably also change the background position property of this element. That's because right now the background is starting to display from the top left-hand side of the image. And that wouldn't work all right if the size of our background image and the size of our original image were not the same. So generally, we're going to want to specify that our background first draws from the top right. In some instances, we'll also want to specify that our background doesn't repeat, which is what it does by default. So let's save that and take a look in the web browser. Fantastic. This is the basic concept behind the sliding doors technique, which allows us to create buttons and other elements that will resize at will, because when we resize an element, we're also going to change the positioning and area covered by its background. Have you noticed that our explicitly no padding, no margin, no border elements are not actually flush with the sides of our page? That's because there's a margin around the body of the page. We can change that, of course, by accessing the page's body and setting its margin explicitly to 0. Now our elements will display perfectly flush. Let's explore one more instance of what sometimes looks like mysterious behavior. To do this, we're going to change the display of those second and third collections to be block rather than inline. This will cause them to display one on top of another rather than next to each other. Now, I've set up ID selectors for all of these elements. So 4 ID selectors in total. And the first 2 are left and right -p. We're going to separate these elements, which remember are one on top of each other, using padding. And we're going to separate the other 2 elements using margins. All right, so let's, for our left element, which is now displayed on top, let's change the bottom padding, well, padding bottom, to be 10 pixels. We want it to be pretty visible. And of course, we're going to change the padding top of our right element. For our left margin element, which is now on top, let's change the margin bottom to be 10 pixels. And for the right margin element, which is now on bottom, let's give it a 10 pixel top margin. If we save this and take a look in our web browser, we'll notice that the images are now displayed on top of each other, and they are separated by paddings and margins. But even though we declared the same pixel size of our paddings and margin, the elements separated by margins are separated by less distance than the elements separated by padding. Specifically, they're separated by half the distance. This is a CSS feature known as margin collapse. We generally see it in the horizontal margins, or the ones that determine how far above or below an image is from each other. This only happens when there's nothing in the way of margin collapse. And what it is a smaller or evenly sized margin disappearing or collapsing into a margin that contains it in its entirety. You cannot collapse across half a margin, for example. CSS generally does a very good job of determining when a margin collapse is appropriate. It's there so that your web pages compress to the smallest vertical size that's reasonable for maximum viewer experience. Margin collapse, for example, won't ever occur on elements whose overflow is set to anything besides visible, and it won't occur on elements who are displaying inline block. While we're at it, let's take a look at another discrepancy between how paddings and margins work. Let's get rid of the padding and margin on our top elements, and then change the padding and margins on our bottom images to be negative. The elements in the middle of our page, which were separated by padding, have ignored our negative padding declaration. That's because CSS doesn't observe negative padding, so don't try and use it. Down here, though, we see that negative margins do exist. We assigned a negative margin to the element on the bottom, and now it's encroaching on the space of the element above it. That's because where the content area of this element begins, right here, and where its margin begin, right there, are no longer in sync. Just like adding a margin of 50 pixels would force this bottom element away from the element above it, adding a negative margin of 50 pixels allows this element to start displaying its content area before its actual margin has been reached. So that's our list of topics for advanced padding and margins. We saw a couple instances where things could go wrong, things that aren't necessarily easy to detect or for whom other explanations may appear to be apparent. We saw that we could change the margin of the body of our page to let elements be flush with it. And we explored the basics behind the sliding door technique and other techniques which allow one element to appear to display two images. It's important to remember that CSS has very specific purposes in mind for paddings and margins. Changing padding allows us to modify essentially the element-specific area of our HTML. We can use padding to increase or decrease the size of an element's background area, for example, things that display and appear and function like part of the element. Whereas margins are intended to be used to describe how an element displays and places on a page in terms of the other elements on the page and their margins. In this video, we'll be taking a look at an in-development CSS3 feature, the transform property. Transforms allow us to rotate, scale, skew, and even reposition the visual portions of our element, while essentially keeping their margins where they used to be so that the rest of our page is unaffected. Eventually, transforms will allow us to do all these things in three-dimensional space, which is really new for web development. However, this is currently only supported by a couple web browsers, and even those only support it in a very rudimentary, not full-featured sense. However, in this video, we will be going over how the basics of 3D transforms work. That way, we're ready to hit the ground running when all web browsers support 3D transforms to a significant degree. The page we're going to be modifying in this video contains two identical image elements right next to each other. I've gone ahead and created separate ID selectors for these two images. I've also given them visible borders, outlines, and paddings by declaring a green background color so that we can see our transforms transform not just the content area of our elements, but also their padding, border, and outlines. Before we jump into any code though, let's talk about what it means to us as developers that we're working with an in-development CSS3 feature. Transforms are listed by W3 as a working draft. That means that the transform specifications W3 has come up with are probably going to stay just the way they are, but W3 reserves the right to change them. This is the reason that not all major browsers have fully supported transforms yet. Specifically, three-dimensional transforms are only supported by a couple of browsers. On the flip side, this means that a couple of the quirks that we need to work around, and we'll be discussing in this video, may not be present in the final CSS3 implementations of all the browsers. To begin with, let's explore 2D transforms. These are transforms that operate solely in the X and y axes that traditional web development has been confined to. All major web browsers currently support two-dimensional transforms. We can use 4 different types of transforms to change how our objects display. These are translate, which repositions an object, rotate, which rotates an object, scale, which will stretch an object in one of a number of directions, and skew, which we'll explore last. However, we access all of these options through a single function, the transforms function. Because this is a CSS3 feature, no major web browsers currently use the transform function. They all use alternative naming. So we need to write identical rules for all of our transform functions. A rule prefaced by -moz, -webkit, -ms, and -o to support all the major browsers. I'm going to be viewing our web page in Google Chrome. So the only thing I need to view our CSS properly in my personal browser is the -webkit header. I'm just going to be using rules prefaced with the -webkit header so that you don't have to sit through me writing 5 separate rules every time we want to change our CSS. If you're following along, you can write all 5 rules or just the rule for the browser that you're using. Now, back to our transform function. Like I said, there are 4 different kinds of transforms, but we're only going to use one line of CSS to declare all of these different types. Inside of our transform function, we're essentially going to create smaller functions for each of the types of transforms. Let's make our first goal to move our left image, when we hover over it, because we're in the hover selector, to the right by, let's say, 90 pixels. This is a translation. So we're going to declare a translate modification. Rather than using the colon of a classical CSS function, because we're already inside the transform function, we're going to use parentheses. This may look a lot like the functions of some programming languages you might be familiar with. Inside these parentheses, we're going to declare our value, in this case 90 pixels, a 90 pixel translation. The translate will occur to the right because that's the default translate direction. All of our transform rules also have slightly different wordings. For example, if we wanted to translate our image upwards, we would use translate Y. Let's explicitly say translate X, just so there's no confusion. We're going to be moving our image 90 pixels to the right. The positive X direction is the right, and the positive Y direction is straight up. So let's save that and take a look at our web page. Don't forget to refresh your page. And we don't expect to see any change until we mouse over this left-hand side image, at which point we expect it to move 90 pixels to the right. So let's do that now. And our image moves as intended. Notice that the image to the right didn't react in any way. Essentially, we've moved all of the left-hand side image except for the margin, which we've left just the way it is. So the positioning of the other elements on our page has not been changed. Because of this, we can often make the claim that transforms are just visual changes. But this isn't entirely 100% true. We can see this by mousing over the very left-hand side of our left image. And if we move the mouse, we'll notice that the image kind of flickers back and forth. That's because our hover selector doesn't actually select by the margin, it selects by the border or content or padding of our image. So when our hover selector moves the image away, it's actually deactivating itself. We know that we can also stretch and compress the elements on our page using scale transforms. We do this with the scale keyword. And just like translate, scale is equivalent to scale X, a scaling across the X-axis. And we could also use scale Y. and eventually all web browsers will support Scale Z. Rather than giving pixels, we give a fraction amount to scale an element. So a scaling of 0.5 will make the element half the size it was originally, in this case across the x-axis. And a scaling of 2.0 will make the element twice the size it was originally across the x-axis. So let's scale our left image in the y direction, so vertical scaling, and let's make it half the vertical height it used to be. What we probably expect now is that our left image will always be half the height it is right now, and when we mouse over it, it will move 90 pixels to the right. Let's go to our web browser, and we're going to see that this isn't actually what occurs. So at first, our web page looks pretty good. Our left-hand side image is 50% of the height it used to be, as expected. But when we mouse over this image, it moves to the right as our translate rule dictates, but our scaling rule is lost. The image returns to its normal vertical height. This is because even though one is a transform scale rule and the other is a transform translate rule, they're both transform rules. And just like two different background colors would overwrite each other, our translate X transform overwrites the previous transform because our hover rule is more specific than this general ID selection rule. This doesn't mean, of course, that we can't have a translate and scale rule exist in synchrony. We just need to declare them both on the same line. So to preserve the scaling of our left image, even when our hover rule is in effect, we need it to exist on this transform line as well. To declare multiple types of transform in a single line, we simply separate them by spaces. If we comma separate them, it will not work as intended. So let's save that and take a quick look to make sure that our page now works as intended. Now when we mouse over the image, it still moves to the right and it maintains the 50% scaling. Transforms also allow us to change how the elements on our page look by skewing them. Let's say that all elements on our page are contained by a box, which they are. This box by default contains 2 horizontal and 2 vertical sides, which intersect at right angles, 90 degrees. When we change an object's skew, we're changing the angles of intersection. So a skew of 0 degrees will have no effect, no change. We can skew X or skew Y. And I find the best way to think about it is this. If we skew an object across the x-axis, the horizontal lines containing that object will not change their angle, but they will move left and right. If we skew an object across the y-axis, the vertical lines containing that object will not change their angle, but they will move up and down. The horizontal lines will have to change their angle to accommodate the new angle of intersection. So let's skew our right image across the x-axis, and let's skew it by 45 degrees. Skews are generally used to give the impression of the object moving in 3-dimensional space even when it's not. So you may often see skews like this, where a default skew function declares both the x skew and the y skew in turn. For our purposes, so that we can see exactly what a skew across one axis does, let's just change the skew across the x-axis. And here's our 45-degree x-axis skew. What we've done is taken this angle here and moved it halfway from where it was, 90 degrees, to perfectly flat 180 degrees. if we had skewed our object a whole 90 degrees across the x-axis, we would have been defining a straight line for both of these sides. Not possible, and our object wouldn't have displayed at all. The last transform function for us to look at is a rotation transform. When we were adding our scale transform, we saw how an object can't be affected by two different transform rules, and that sometimes we have to declare in the same transform rule different types of transforms. However, we can kind of affect an object with two transform rules by applying one of the transform rules to an object that contains it. The transform will trickle down in the sense that the containing object will have been moved, rotated, scaled, or skewed along with everything it contains. So let's apply our rotate rule to the body of our page. We'll just rotate our entire page 15 degrees. And we will expect all of the elements the page contains, including these images, which already have their own transforms, to rotate 15 degrees and also display their existing transform rules. This is different from what we originally tried to do with our two scale rules because the two transforms are not actually applying to the same object. The body element of the page is a different entity from the left image. Now let's talk about syntax for rotation. The default rotate rule, given only a single parameter, is synonymous with rotate z. To understand what this means, we need to understand what the z-axis is. The x-axis, of course, is a horizontal axis. It goes left to right. And the y-axis is our vertical axis, which goes up and down. The z-axis goes into our computer screen. The z-axis in the positive direction is towards us, moving out of our computer screen. And the z-axis in the negative direction is away from us, the viewer, moving into our computer screen. That means if we rotate something around the z-axis, an object that just displays in the x and y axis right now, will be changing only space in the x and y axis. However, if we were to rotate an object around the x or y axis, an object that was two-dimensional to start with, we would be moving part of that object into z space, essentially making it three-dimensional. For this reason, Internet Explorer and Opera, which don't currently support any three-dimensional transforming, won't observe rotate x, rotate y, or rotate z. So for them, we can only use the default rotate. And of course, we can give it both an x and a y value, if that's easier for us. Oops. For now, let's just be content with a 15-degree rotation around the z-axis for our entire page. Save that and we'll take a look. Okay, and there's our rotated page as expected. Now we're going to talk about transforms in 3 dimensions. Internet Explorer and Opera right now do not support 3D transforming at all. If you can, I highly recommend you use Google Chrome for this bit of our tutorial video if you're following along. That's because Google Chrome currently boasts the most support for 3D transforms, but it's still not fully implemented. I'll show you one of the areas where implementation is not complete as we go through this. Let's start by simplifying our page significantly. Let's actually get rid of all the transforms we've written so far, just so we don't confuse ourselves. And so we'll start with this ID selector for our left image. What I'd like to do is rotate these images across the y-axis. This is going to move part of the object into z space. And because they're touching each other along a vertical line, if we rotate both images across the y-axis, we should be able to make them face each other to some degree. So let's have our y rotation for the left image be 30 degrees. And then so that the right image faces the left image in equal amount, we'll have it rotate negative 30 degrees. Let's save that and take a quick look. All right, this page doesn't quite look like what we've tried to define. We can tell that something has occurred because there's now space between the images where it wasn't before. The images have been compressed horizontally, but they don't really look like we've turned them to face each other. Generally, we would say that if we were looking at these two images facing each other from above, we would expect the inner sides of the image to appear shorter to us than the outer sides, because objects further away look smaller. The reason we're not getting that from our web browser is that we haven't given it enough information for it to concoct that bit of the three-dimensional display. Sure, the web browser knows that our images have been rotated, but what it doesn't know is what point of space we're looking at them from. We call this idea of explicitly declaring a viewpoint for a three-dimensional element, or placing a camera to look at it, if you will, perspective. The idea of perspective gives us a lot of insight into how 3D is implemented in CSS. Because elements have their own perspective, they aren't really 3D in terms of each other. Rather, they're 3D elements photographed and then placed as 2D images on our page. We're not going to do it here just because we can explain it just as well, but if we were to move this right image positively along the z-axis by translating it so that it was, in the three-dimensional sense, closer to the viewer of our web page than this left image, and then place the images on top of each other, we would actually still see the left image, because while it is further away in 3D space, the two pictures taken of our images from their perspectives are still displayed using the normal rules of element priority. And in this case, our left image would display first. So let's go ahead and give the web browser viewing our page enough information so that it knows how our three-dimensional object should look to the viewer. We can declare perspective in two ways. The first way, which we're doing right here, is to declare it right in our transform. This is perspective in terms of the element that we're modifying. And all we need to do is tell the web browser how far we would like that imaginary camera positioned from the center of the element that we're looking at in terms of pixels along the z-axis. So I'm just going to use 1,000 pixels. So now the viewer of this element should see it as though they were 1,000 pixels out of the screen, directly from the center of this element. So let's save that and take a look at our web page. We'll see that our images now kind of look like they're facing towards each other. Of course, it's still a two-dimensional display because, well, we only have a two-dimensional screen. But their inner edges are shorter than their outer edges, as we would expect two three-dimensional pictures face towards each other to appear. This is not a perfectly lifelike view, though. And that's because each image has been given its own perspective. We're looking at each image separately as though we were simultaneously directly above both of them. That's kind of an odd statement to make, so let's use a visual example. We don't have to declare perspective in our transform function. We can declare it outside of the transform function in an element which contains elements that have transform function. we should not declare perspective outside of a transform function in an element that does have a transform function. We just do this with the perspective rule, and we simply give as a value a pixel distance across the z-axis, like we would do if we were declaring perspective within a transform function. So what we've done here, because the body element contains both of our images, is said that rather than placing two separate cameras above each of our images and looking down and taking two separate pictures and placing them on our web page, we'd like to take our pictures from the same location for both of those images. In this case, a location that is 1,000 pixels out of the screen from the center of our web page. Let's see what that looks like. And so here we see that the images are not actually reversed carbon copies of each other. Because we're looking from the center of our screen, the width of our further away image appears larger. One last thing to mention about working with 3D transforms is that on some level there's a performance cost. Serving a web page that uses three-dimensional transforms shouldn't make, at least to any reasonably significant degree, the actual information sent from the server to the client any more sizable. But what it does require is that the client process the physics of the 3D transform. If you were to create a web page that had many 3D transforms or relied on complicated 3D transforms, it could be difficult for machines viewing that web page to keep up. It will probably be some time before 3D transforms are supported in all the major web browsers. But when they are fully implemented, we should be well on our way to mastering them. I'll see you next time. In this video, we'll learn about CSS3 transitions. Transitions allow us to describe functional, gradual state changes in objects. They're a very rudimentary form of animation. Our goal for this video is to take this link right here that's just kind of stuck on this web page and turn it into a very neat, very functional, very useful element. We're going to remove it mostly from visibility on the web page. We're going to turn it from an obvious link to a little tab that exists on the left of our page. And then when the user mouses over this tab, we'll have it animate outward and display the link or whatever it contains. Before we get into the code though, let's talk about what it means that transitions are an in-development CSS3 feature. Most importantly to us right now is that Internet Explorer does not currently support CSS3 transitions. So if you'd like to follow along with this video, you're going to need to view your web page in a different browser. Any other major browser should be fine. Before we really need to call upon CSS3 transitions, we need to do some other CSS styling to our element to get it to behave the way we've described. So let's assign a class to this element so that we can modify it. We'll call it the slider class. And the first thing we'd like to do is position our element. Right now it's positioned in the general flow of the page below the general context of the page, which is this paragraph element. And because we're essentially making a filing cabinet tab that we'd like to just sit on the left-hand side of the page, having our link appear below all the text on the page isn't really convenient for the user. This seems like a good opportunity for us to use absolute positioning. And if we couple that with a 0 pixel left positioning, our element should appear to come right off the left-hand side of our page. The other thing we're going to do is assign a top position. So our element will start 200 pixels from the top of the page. I'm going to put this bit of our CSS code away from all the other code because in reality, if we were to be creating a reusable slider class, we would probably be declaring this value somewhere else, not in the general class, which applies to all elements. That would keep us from being able to use multiple sliders on the same page. In addition to positioning, let's explicitly set the height of our element. And let's spell it right. And let's just use a height of 30 pixels. Let's also explicitly set the line height, which is the height that text is allowed to display in, so that text larger than what we're using right now won't destroy our element. So let's save that and take a quick look in the web page and see what we've done. All right, so there's our link. It's in a good position for our tab, but of course it's always visible, and that's not what we described. We want a small, unobtrusive visible bit that we can hover over to display the entirety of the link. The first step to achieving that is to make it by default mostly invisible. We can do this pretty efficiently with 2 lines of CSS. First, we can change the width of our element to 0 pixels. There's now essentially no content area. And then following that, we're going to need to change overflow to hidden. That's because by default, the text in our anchor element will still display as it overflows the content area. If we save that and take another quick look, we should see our element disappear. For all intents and purposes, it's not on the page right now. Of course, that has the unfortunate side effect of us not being able to hover over this tab to cause it to fully display. We're going to circumvent this issue by giving our element 15 pixels of left padding and a colored background. Now, the user of our web page will see that 15 pixels of left padding, and they can mouse over it, and the padding is a functional part of the element. We can make one more cosmetic change here that's going to cause our element to look much more finalized and high quality, and that's adding a border. Rather than adding a border around the entire element, let's add a border to the top, the right, and the bottom. Let's just have it be a black 2-pixel solid border. Not having our border on the left will further create the illusion that the element is protruding from the left side of the page. While we're at it, we can make use of a CSS3 feature here. We can use our border radius. And that's border. So we only want to add the border radius to the top right and bottom right corners of our element. And let's just have our border radius be 5 pixels. Now, this is a CSS3 function, so we need to write redundant lines of code. I'm viewing my web page in Google Chrome, so for the sake of time, I'm just going to write redundant WebKit lines, which is what Google Chrome uses. You should use whatever works for the browser that you're working in. So let's save all of this and take another look. There we go. Now our element really looks like a tab off the side of the page. Okay, that concludes an extremely quick and dirty CSS review. We're going to slow down a little bit now while we cover the actual topic of this video, CSS3 transitions. So in order for our element to transition, it needs to have 2 different states to transition between. right now we have a general state for our slider element declared. Let's write a rule for an alternative state. We use the hover pseudo selector to declare a state when the element is moused over. When this state occurs, we'd like the element to display its contents, in this case the link it contains. What keeps our element from displaying its content normally is this rule right here, this 0 pixel width, which essentially removes its content area from play. When we've moused over our element, let's change the width to have enough area for the actual link to display it. Let's say that when we mouse over our element, the width will be 80 pixels. Let's take a look at that in our web page really quick. And there we go. When we mouse over this little tab, we can see the link, and it's a functional link. We can click on it and everything. Here's where transitions come into play. That's a pretty useful bit of CSS we've done already. It allows us to unobtrusively insert navigation links into our page, but we can make it look really crisp by having that link slide out from the side of the page rather than appearing immediately. This is what CSS3 transitions allow us to do. They allow us to create a number of steps in between two states. So let's talk about how CSS handles transitions. In order for us to create a CSS transition, we must have first defined two unique states. We've done this. We have one state in which our width is 0 pixels and another state in which our width is 80 pixels. But we don't so much span CSS transitions across states as much as we stick them to an element and span the transition across a type of rule. So let's take a look at transitions syntax. I'm just going to go ahead and put my WebKit header, and then we use the transition keyword. Now, a CSS transition has two variables. The first is the type of rule that we'd like this transition to apply across. In our case, we'd like to see a slow transition between widths for all slider elements. So that's our first variable. Just the name of the rule we're applying this transition to. The second bit is how long we'd like this transition to go on. And we specify this in seconds. So let's have our transition be a 2s or 2-second transition. Now, whenever our element changes width, it will create that width change over the span of 2 seconds. Let's save that and take a look. So here we go, mousing over our link. It goes through all the intermediate states between 0 width and 80 pixel width. We can see that our link only displays fully after the click me can fit entirely in the content area. While if we were making a final product, this would be kind of bothersome for us, it shows us that transitioning elements are fully functional. For example, if we'd applied this transition across a rotation, we would still be able to highlight and click on the link as it was rotating between states. We've now successfully employed a basic CSS3 transition. They're deceptively simple. Let's take a look at a couple other things we'll probably want to do with transitions. If you have really sharp eyes, you might have noticed that the tab element we've been creating didn't pull out from the left of the page, or appear to pull out from the left of the page, at a steady speed. In addition to the default transition function, where we assign these values, we're also going to want to use sometimes the transition timing function. The reason that our tab element didn't move at a consistent speed is that its transition timing function by default looks like this, ease. This says that the transition should occur slowly at first, quickly in the middle, and then slowly at the end. We can also use ease in to create a transition that begins slowly and then ends at full speed, or ease out to create a transition that begins at full speed and then ends slowly. We also have a cubic Bezier option, which takes 4 values from 0 to 1 and creates a speed function from that. Going into how this works is a little beyond the scope of this video. And of course, we can say that we would like a linear timing function where speed will be constant throughout the entire transition. Let's stick with that for now. So right now our transition only affects the scope of changes in width. Let's say that we wanted our displayed link to also change its background color. Let's say something like this. This right here would cause the background color to change instantaneously when we hovered over the link, which we might want. Or we might want the background color to change over time as well. We can add more rules and time pairings to our transition by comma separating the pairings. Oops. So let's go ahead and add background color to our transition rules. And we don't have to give it the same time transition as we did our width. Let's have background color change slowly over the course of 5.5 seconds. Let's save this and take a look at our web page and see how that looks. Pretty cool. You may or may not have caught the linear transition speed, but I expect that you can see the background color slowly changing over time. CSS3 transitions, which you should be pretty comfortable with now, are really great because they make our web pages look professional and polished and allow us to create controls that have some dynamic functionality without the use of things like JavaScript, just through CSS. They're also deceptively easy to use. There's not that much to them. I think they're pretty intuitive. Perhaps most excitingly, they're our greatest major stepping stone on the way towards full-blown CSS3 animations. See you next time. CSS3 gives us the ability to apply animations to our HTML objects. This video will take a look at how it's done. Let me begin by telling you that Internet Explorer does not currently support CSS3 animations. If you'd like to follow along with this video, you should view our page in a major web browser that is not Internet Explorer. CSS3 animations are very powerful. Like transitions, animations allow us to describe how an HTML element changes from one state to another. Unlike transitions, animations also allow us to specify what these states are going to be. To see what exactly this means, let's begin by adding a very simple animation to our page. Our page currently contains a paragraph element, and the associated CSS simply defines a width and height for the element and says that its background color is red. Let's have our first animation change the background color of this paragraph element from red to blue over the course of a couple seconds. Even though we're assigning an animation to this paragraph element, we're not going to begin our code in the rule that selects it. Rather, in a separate CSS rule, we're going to define how our animation operates. Then we're going to place that defined animation within the rule of the paragraph selector. This allows us to attribute a single animation to multiple different types of elements who share similar starting conditions. CSS3 thinks of animations as a series of keyframes. each keyframe is a state that we'd like our object to pass through over the course of its animation. So to begin defining an animation, we're going to define all of the keyframes we'd like it to use. We do this in a separate rule, prefaced with this @ symbol. And then the keyword we're going to use is keyframes to tell CSS that we're about to write some keyframes. Of course, this is a CSS3 feature that's not currently supported in the general text of the major web browsers. So we're going to need to add a browser-specific tag before our keyframes keyword. I'm going to use the WebKit tag because I'll be viewing these pages in Google Chrome. You may want to use the -o or the -moz tag, depending on what browser you plan on viewing your page in. As always, for a finished product, make sure you also include the untagged version of the rule for when CSS3 is supported in the general text of the major web browsers. Within this rule we've just created, we can begin to define some keyframes. The identifier for each keyframe is at what point in time during the animation does the keyframe occur. However, we don't use the concept of seconds for keyframes. Rather, we say what percentage of the animation has completed. So, a keyframe that declares how our animation will look at the very beginning is the 0% keyframe. The keyframe that declares how our animation will look at the very end of the animation is the 100% keyframe. You can also see 0 and 100% expressed as from and to. W3 recommends that all animations explicitly declare a from or 0% keyframe, defining all of our assumptions at the start of the animation. So let's define in our from keyframe our only assumption. And that is that the element we are animating has a background color of red. Then the only other thing we need to do in the keyframes of our animation is declare how the element should look at the very end of its animation. And we've decided that at the very end of our animation, we would like our element's background color to be blue. Because we don't use seconds for keyframes and rather choose a percentage approach, we're giving more power to the element that's going to implement the animation because it gets to decide how long the animation we've described is going to take. There's one thing we need to do before we can assign these keyframes to the animation we're about to create in our paragraph element. We need a way to select these keyframes specifically, so we're going to give them a name right after the keyframes keyword. Let's just call these the color change keyframes. Now we should be good to inform our paragraph element that we have an animation for it. We do this with the animation keyword. And generally, you'll see the animation keyword paired with two parameters. The first, which is mandatory, is the keyframe set it's associated with. And then the second, which could also be done on its own line as duration, is how long we'd like our animation to occur over. So let's have this animation last for 4 seconds. If we save this and jump to our web page, when we refresh the page, we should expect to see our animation occur. And there we go. Our paragraph element transitions from red to blue. You'll notice when the animation is complete, the element transitions back to its default state. Once the animation is done, it no longer has any hold over the properties of our element. To explore the intricacies of CSS3 animations, let's create a more complicated animation. For this second animation, we're going to use a sprite sheet to make a character walk back and forth across our screen indefinitely. So we're going to be using, in this video, the window method of sprite creation. So we have 2 images. The first of these is this little walking man, which I found is a public domain image. And our second image is a transparent image of the width and height that we would like to cover each frame of our little walking man. Before we can animate an image, we also have to add it to our page. So let's go ahead and do that right now. We'll just declare an image, and here's the path I have for my window.png. Save that, and we're back to the CSS. Before our sprite will display properly, we're going to need to assign as its background image the actual sprite sheet that we'd like to use. There we go. Now we should be good to begin animating it. So let's set up another list of keyframes, and we'll just call this the walk animation. Taking a look at our image quick, there are 4 different frames that we'd like to iterate through. So the from and to keywords for keyframes are probably not appropriate here. Rather, we're going to begin at 0% and then jump up by 1/4% for each keyframe. This is, of course, 5 different keyframes of animation. And that's intentional. We'd like our animation to end in the same state that it began. And that's so that we can loop the animation over and over without it making any jumps. So now to tell our keyframes what we'd like our element to look like during each frame. Well, we iterate through the sprites in our sprite sheet by changing the background position of our element to place the sprite we'd like to be viewing at the current point in time behind the window that is the non-background image of the image. So for each of our frames of animation, we'd like to change the background position by 19 pixels. So that's 19, 36, and then finally 57. And for our non-zero values, we need to specify that we're talking in pixels. And then at the very end, when our animation has completed a run through, we'd like it to be back at the very beginning, the first image we saw, so that it will smoothly transition to another run through. Of course, that brings us to the concern, well, the animation we assigned to our paragraph element only ran once. Let's address that now. But first, we need to assign our animation to our image. So this is the walk animation, and let's have it occur over the course of 1 second. Now, to create an animation that loops over and over, we use the animation iteration count option. Here we can specify how many times we'd like our animation to occur. Or instead of an integer value, we can say we'd like the animation to occur infinite times. That'll keep our little guy walking. The other thing we need to do is take a look at the animation timing function. This determines how time is perceived by the animation. As it is right now, our background position will be slowly transitioning from 0 to -19 to -36 to -57 and hitting all of these steps in between. That's going to look very odd for our displaying sprite, as the window will be essentially panning over the sprite sheet rather than jumping from one image to another. We can set the timing function to be step start, which has our animation jump from one defined keyframe to another without hitting the steps in between. So let's save that and take a look at our walking guy in the web page. Okay, he's a little bit off and that's because I did basic math wrong, and this value should be -38. Now he's fantastic and walking forever. Our next step then is to get him to face to the right and walk across our web page. Unfortunately, we can't simply change the image's position, which is how we're going to make him appear to walk, using these keyframes. That's because these keyframes are executing very quickly. We said we want them to execute in total once a second. If our guy were to walk that fast, he'd be zipping across the web page and it wouldn't look nice. We also can't reasonably slow down the execution of these keyframes, or our little guy will cross the web page's screen over the course of 2 steps. So we're going to create a separate set of keyframes for move, to have our guy move across the screen. We'd like this to happen again and again as well, so we're going to declare 4 states. A start state, a halfway state, this 51% state, which is immediately after our halfway state, and then our end state, which we're going to have look the same as our start state. To have our sprite character appear to be moving, we're going to change the position of the image element. To make it easier on our animation, let's declare that positioning in this image element is relative. This means that changes in position for our element will happen relative to its original location. So when I say left 20 pixels, I'm moving this element 20 pixels from where it was at the very start. However, for our 0% starting keyframe, we'd like our element to be right where it began. This 50% keyframe is halfway through our animation, and our entire animation loop is the element walking from the left side of our page to the right side of our page back to the left side. So when our animation is halfway through, we'd like our element to be on the right side of our page. We don't want to use pixels for this. We want to use a percentage to accept all page widths. So when our animation is 50% complete, our image element will be on the very right-hand side of the containing element, which is the body of the page. This just above half element, we're also going to set to be 100%. And you'll see why this exists in just a moment. And then we'd like our animation to end on the very left-hand side of the page. So between these 2 keyframes, our element will be walking back. Between these 2 keyframes, our element will be walking from the left-hand side of the page to the right side of the page. Now, the other thing we need to do, aside from creating that walk animation, is flip our element, because right now he's facing the wrong direction for his walk from the left side of the page to the right side of the page. Let's just use a transform for that. And an easy way to flip an image is to scale it to -1. And so that will have our guy facing towards the right-hand side of the page for the first half of his animation. Then for the second half of his animation, we're going to have to tell him to go back and face the way he was by default. Now, this is pretty good, but it leaves us with a couple issues. First off, we've already assigned an animation to our image. We already have it doing the walk animation, and now we want it to move as well. Well, we can assign multiple animations to this animation rule by comma separating them. So now we'll have him completing a walk element every 1 second and a move from left to right back to left every 20 seconds. Our animation iteration count of infinite is great for both of these states, but step start certainly isn't acceptable for our move keyframes. That would cause our animation to wait 5 seconds and then move him to the right-hand side of the screen, then wait another 5 seconds and move him to the left. Fortunately, we can just comma separate this as well. Let's have our move animation occur in linear time. So let's save this and take a look in our web browser. He's walking upside down. Oh, and that's because we didn't scale explicitly across the x-axis. If we save that and refresh, there he goes, walking across the page, and we'll kill time for a second or two to see if he turns around properly. And he does, and he should keep doing that infinitely. Prior to CSS3 animations, we really had to rely on languages like JavaScript to create these visually appealing effects on our web pages. It's W3's hope that adding this powerful animation support to CSS will reduce our need to rely on other languages that we could do without otherwise, keeping smaller projects much simpler and confined to a couple languages and technologies. Thanks for watching. Nothing turns CSS into an exercise in frustration faster than when the elements on our page don't appear where we expect them to. So in this video, we'll be taking a look at CSS's display property, which allows us to select from some default behaviors for how our elements order themselves on the screen. Let's begin by taking a look at the page we're going to be modifying. I've divided the page into 2 sections for our convenience, these 2 gray boxes, and they should act in all ways independently for the purposes of this video. I've also done some basic visual styling inline in our HTML, so that the CSS code that we're going to be modifying we can keep very clean and simple. We have 2 CSS rules. This first rule, the column 1 ID selector, refers to this blue test text right here. This is a span element contained between 2 other span elements. We also have a class selector, which refers to both of these red blocks. These are both div elements, which I've given different widths and heights. In addition to some basic color styling, you'll see that I've explicitly defined display rules for all of our elements. Currently, these rules are unnecessary. Our span elements would have defaulted to display inline anyway, and our div elements would have defaulted to block display. If I was to remove both of these display rules, our page would not change in any way. So let's take a look at the difference in the behavior between the elements displaying inline on our left and the elements displaying block on our right. The most obvious difference is that the elements on our left are allowed to group horizontally. This is the first span element. It ends right here. Then afterwards, our second span element begins right away. The third span element begins right after that and wraps down to the second line once the content area of the containing box is reached. It certainly seems that the div elements on our right side could have managed this. This second larger div could appear to the right of this smaller div, but they choose not to. When our browser begins rendering elements displaying block, like these elements, it begins by jumping down to a new line. And then when it finishes displaying a block element, it creates another new line. This causes block elements not to tolerate elements on the same horizontal axes as them. While they might appear simpler at first glance, elements displaying inline are actually a little more complicated than this. If we click and drag over inline elements, most browsers will highlight the text for us, and we can see the lines that our CSS has designated. A line can be any height. It will be the height of the largest element it's required to contain. And a line will continue displaying the elements within it until it reaches the end of the content area that it's allowed. And then a new line will appear beneath and the elements will continue to display. To help us visualize how we can have CSS think in lines, let's modify the line of these elements. Let's change the line height of this element to 50 pixels, which should be a little larger than it is right now. If we do that and refresh the page, we'll see that the distance between our text has changed. If we do our click and drag, we can highlight the lines that our span elements appear on, and they're larger than they were before. This second line is larger than it was before as well, even though we've only declared the line height to be 50 pixels for this span element that I've highlighted right here. That's because in CSS, display is element driven. So this last span element begins on this line here, where we've declared that the line height must be at least 50 pixels. This element must adhere to that rule for part of its display, the display up here, and carries this ruling with it for the rest of its display. If we jump into our HTML quick and add some more spans to this part of the page, we'll see that these spans down here, which are not affected by our line height ruling of this blue text, return to their default line height when able. Now, we're learning about the display rule so that we know when to use it. So let's take a look at what happens when we change these elements' display properties from their defaults. Let's change the display of the blue text among our spans to block. And let's ask our divs to display inline style. Let's begin with our spans. As we know, block elements force new lines at their beginning and end so that they don't display horizontally next to any other elements. So, by declaring that this span displays block, we've forced it to separate out the rest of the spans into two groups, those above it, which were the ones before it, and those below it, which is everything that comes after. More dramatically, our div elements appear to have disappeared. That's because they're now displaying within a line. And as we know, the height of a line is the height of the largest content it needs to contain. Our div elements have declared heights, which allowed us to see their background color when they were displayed block. However, when elements are displayed inline, the personal heights we've assigned them do not matter. Only the height of the line that contains them does. So our divs have essentially been reduced to the height of the line containing them, which is 0 because there's no content within them to force it to have an actual height. This demonstrates in its own way a third display property, none, which will cause an element not to display at all. If we change our span element to display none, it will take up no space in the line. But what if we'd wanted our divs to display next to each other, left and right, like our inline spans did? There's actually a rule for this. When we want block elements to ignore the forcing of new lines at their beginning and end, we can have them display inline block style. This causes a line to form around our block elements, which we can see by holding down the mouse and highlighting the area in between them. it's a line large enough to contain the largest block element. And then it allows the elements to display horizontally next to each other by not forcing new lines. And those are the basics of the display property. In addition to the inherit value that we see with most CSS rules, there are a number of other names we can give to display property values. However, we're only going to use most of these names when we're trying to do something extremely specific. They exist to describe how table elements and list elements display with each other. Making good use of the display property when we're setting up a web page is important. The inline block or inline block display styles describe the basic setup of our page. The more accurately we describe how we'd like elements to display with the display property, the less really direct positioning we're going to have to do to those elements later. I like to think of the display property as our first step towards getting our page's elements aligned the way we want them. Rather than putting an element in a very specific position, we're simply telling CSS what kind of elements we're creating at this point in time. Thanks for watching. This video will take a look at the intricacies of the CSS position property, which tells our elements how they're going to display on our web page. It works closely with the top, bottom, left, right, and center offset rules. Let's take a quick look at the page we're going to be modifying. We're going to be assigning different positioning values to this blue backgrounded span, which is among many other spans on our page. You'll see right now that I've assigned this blue background span a position value of static. This is the default value for just about every HTML element. Static positioning means that this element, along with all the other span elements on the page, which are positioning default, which is static, will display according to what we call normal flow. They're all line elements, so they'll simply follow the rule of line element display, starting from the top left of our content area and ending at the bottom right. The important thing to realize about static positioned elements is that it disables our ability to offset their position with commands like top, left, right, bottom, or center. If we specify a top offset of 100 pixels for this element and then refresh our page, we'll see no change because the static position rule explicitly says that this element will simply position based on the normal flow. Let's take a look at this behavior from a conceptual viewpoint. Why would statically positioned elements not do anything when we attempt this offset of 100 pixels? Well, this implementation decision was made because offsets are going to have different behaviors based on what position option we choose. Let's take a look at relative positioning. If we instruct our element to position relatively and then attempt the same 100 pixel top offset, our element is going to display 100 pixels below where it would have normally. We have moved the element 100 pixels from its original top. The important thing to notice here is that the area the element originally occupied is still physically occupied. We've only moved the visual portion of the element. Physically, it still displays in normal flow. We can create positioning offsets from points of reference that are not an element itself. Let's take a look at absolute positioning And we'll simply leave that 100 pixel top offset. If we save this and refresh our web page, our element appears floating in the middle of the page. It's now obscuring the other spans, and the physical space it originally occupied is gone. This tells us that positioning an element absolutely does two things. First, our offset is no longer in terms of where the element was originally. If it was, we would expect our element to display somewhere around here, where the relatively positioned element displayed. Rather, it's displaying 100 pixels from the top of our page. Or, more specifically, it's displaying 100 pixels from the top of its containing element. We can see this a little more obviously if we change its top to 0. No offset from the top of its containing element, the body of our page. The other important thing that absolutely positioning this element has done is it's physically taken it out of the normal flow. So the space that it used to occupy now no longer exists. This is very similar to what our last positioning option does. Position fixed. If we choose our fixed position and refresh this page, at first it will appear that nothing has changed. However, when we go to scroll down this page, our element will stay with our visual display. Whereas position relative positions an element in terms of its container, which for our purposes here is the body of our page, position fixed positions an element in terms of the view of the browser. While we're on the topic, let's talk about how offsets work very quickly to make sure we're all on the same page. What we've explicitly stated with this top 0 offset rule is that the distance between the top of our element, this target element, and the element that we're offsetting against, as defined by our position rule, currently the actual view of our web browser, should be 0 pixels, and that the element whose rule this is will be responsible for moving to create that offset. So of course, if we declare a 50 pixel offset, our element will move down 50 pixels to create that reality. We can also declare offsets in terms of a percentage. A 50% offset, top offset, is going to say that the top of our element is 50% of the way between the top and the bottom of its containing element, which is not the page itself, it's our browser viewpoint currently. Left and right offsets work the same. I show you this because when I was learning offsets, I attempted this code to position an element in the bottom right-hand corner of the screen. I said I would like my element 100% of the way on the bottom of my page, and I would like my element 100% of the way to the right. This, of course, causes the element to disappear, and it's not even disappearing past the bottom right of the screen. It's all the way up here in the top left, too far to the top left to display on our page, because the right of the element has moved 100% of my viewport all the way off the screen, and same with the bottom. The proper way to do this is to simply specify that the bottom and right sections of our element should be 0 distance from their corresponding elements in the container. Let me also show you an offset-like rule, the z index rule. Z-index allows us to declare when elements should display in front of or behind other elements. The lower our Z-index value, the further away from us an element is in terms of what elements will display in front of others. If I set the Z-index of our element to -1, it will now display behind the other elements on the page, which have positive or 0 Z-index values. While CSS3 has been attempting to add a genuine Z-axis to our view of web pages, the Z-index achieves its effect simply by drawing other elements in front of each other. It's a CSS2 property, and there's no physical Z-axis. No matter how small we make our Z-index number, the element is not going to shrink as it moves further away from us. At the end of this video, you should feel pretty comfortable with positions and how they affect our offset rules. Using positioning and offsets, we can really get the elements on our pages to appear anywhere we'd like them to. Remember though, before you go aggressively positioning your elements, do your very best to get your page looking generally what you want it to look like, using the simpler, less intrusive options of inline and block styling. Thanks for watching. This video will cover the CSS float property, which we can use to fill some gaps in the functionality of the display and positioning tags. Let's take a look at the page we're going to be editing. This page consists primarily of span elements, all the text on this page. Because they're span elements, we know that they've defaulted to inline display. We also have this red box on our page, which is simply a div with a fixed width and height, and of course a background color so that we can see it. As a div, this element has defaulted to block display. That's where the line break between these spans and the div come from, and the line break after this div before these spans comes from. Our goal here is to modify this page so that our red box displays in what appears to be the general flow of the page. We want to remove this unnecessary white space and have our text encompass all the space of the page that is not actually this red block. You can probably guess that we're going to use CSS floats to do this. But first, let's look at our options using positioning and display tags to see where the necessity of floating comes from. I've assigned this target left ID selector to our red box div. Let's begin by attempting to achieve our styling goals of getting rid of all that white space created by placing a block element amid all these text spans by seeing what we can do simply using the display property. So because we're working with a div element, we know that we've defaulted to display block. And that gave us a large section of white space created by the line breaks placed in the beginning and after a block element. So that's no good. We also know that if we chose display inline, our div would disappear because it contains none of the type of content required to force a line height. So that's not an option either. We've solved similar issues in the past using inline block display. So let's take a look at that in our web browser. What's happened here is that all of our spans up to our div have displayed normally in line. And then of course our div element is displayed in line. Unfortunately, this gives us a large white area above the other inline elements forced to accommodate the div's larger height. So it doesn't look like display is going to give us a very good solution. So let's take a different approach. Rather than changing the method in which our div displays, let's use the position rule to take it out of the content flow of the page. We can use absolute positioning for this, and let's just give it a quick offset while we're at it. Let's pull it to the left side of our page, where it was originally. So our absolute positioning rule has removed our div from the normal flow of the page, thus removing that awkward white space created by having such a large object in the normal flow of not very tall line elements. What's not at all great about this solution is that these line elements have no idea that our red box div exists because it's been removed from the normal flow that they're aware of. So parts of our text on our page are displaying underneath this red box, and that's not what we'd like. We'd like to see our text wrapping or floating around the area controlled by this box. So let me propose a hypothetical solution. Wouldn't it be great if we could take this box and remove it from the normal flow of our page, but still affect the normal flow of all normal flow elements on our page, standard, block, and inline display elements, by changing essentially the area in which these elements are allowed to display in? What we would be doing is cutting out a piece of this containing elements display area, which this box then floats over. And of course, that is an option. There is one catch, however, when using the float rule, and that's that we can only float left and float right. Because of the difficulties associated with wrapping inline and block elements around changes in the area of their container's display area, we can't float an element right in the middle of a content area. So let's go ahead and float our div left and see how that works. If we take a close look here, we'll see that we're not cutting off our span elements in the middle of any lines. They text wrap as they would if they were hitting the side of the page right here. We have succeeded in floating our div over a div-sized area that we've cut out of the display of the page. This is an extremely powerful tool. It's easy to see how using a left and a right div, we can do somewhat complicated things like dividing our page up into two distinct left and right columns. You'll also see divs used a lot to create a line of elements that will display one after another no matter which elements are removed from the row. Because when we float an element, in this case to the left, it's going to go as far left as it can without hitting another floated element or the side of its content area. As with most things, there's a couple of oddities that divs exhibit that we should take a look at here. We'll stumble on the first of these oddities on our way towards me showing you two divs lined up on the same row, like I was just talking about. In order to do this, let's create another div. And while we're originally going to float it to the left next to our existing div, we'll call it target right for now, because eventually we'll be floating it to the right. In our CSS, we're going to create another ID selection rule that looks not unlike our target left one. Let's get rid of this float left line for now, though, and change its background color from red to blue so that we can differentiate them. So right now, this element is not going to float. It's just going to display as a block element. And let's take a look at what that looks like in our web page. So this is kind of odd. Our red div, the one floated left, displays as expected. We can even see some text wrapping around it. However, our blue div, which is the same side, is just poking out from the bottom of the floated red div. This white space is, of course, as a result of this blue div being displayed as a block element, the initial concern we had with our red div creating white space. The reason the blue div is partially hidden by the red div is that we removed the floated red div from the content flow of the page. So, while this is great for line elements, our block element doesn't know where to vertically position itself without the div in the normal content flow of the page. I'll show you how to solve this problem in a little bit, but for now, let's achieve our original goal and float our blue div to the right. Taking a quick look at that, we can see that our text, which looks a little different next to the two divs because it's aligned left, can handle changes in its display area both on the right and left of the same line. We can also float this blue div to the left, and it will move as far left as it can and then cut out its bit of the display area. Our red div has already cut out 200 pixels of display area, so our total display area cut out ends up being 400 pixels wide. Let's quickly float this blue div back to the right and attempt another modification that's going to give us a similar issue as we saw when we did not float our blue div. Let's surround these two divs with a third div, and we're going to assign a class to this div. I'll just call it background. Actually, how about border? Save that, and in our CSS, it looks like I already have the dot border rule here. So we should expect to see a 5-pixel solid black border around our two divs because they're contained within an element that has this border class attribute now. However, if we save this and refresh our web page, we'll see that the border displays all at once on the top here, as though it was encompassing a contained element that had no height at all, which is, of course, what it's doing. By removing our two divs from the normal flow of the page, which is what floating them does, we've removed our containing element's ability to determine how high they were. This is the same root cause that caused our blue div to be unable to determine how far below our red div it should display when it was simply a block element. This is an inherent weakness of floating elements. Removing elements from the normal flow is great in some instances where we like to wrap something around them, or when we simply want to move them to the left or right of our page as far as they will go until they hit the side of its containing element or another floated element. However, display issues like this and our improperly stacked block elements are the price we pay for removing these elements from the normal flow of the page. In some instances, there is a solution. We have access to a rule called clear. So this bit of HTML right here, if we add another div to it, we're placing this div right after our second floated div right after the blue div, but before the end of the containing box, which we'd like to have a border around the divs. And we're going to assign a class to this new div, and we'll just call it the clear class. Let's write a .clear rule, and we're simply going to say clear both. We can clear left, right, and both. And for right now, we're just going to use both for its simplicity. Clear works directly with the div rule. And what it's essentially saying is, after this point, to the right or to the left, or in our case, to both the right and left, we no longer want the div removed from the normal flow of our page. Now, if we refresh our page, we'll see our border display as expected. The price we pay for clearing our divs in this manner, our content no longer wraps in between them. If you have a firm grasp of the position, display, and float rules, you should be able to set up a basic web page in just about any configuration you can think of. Sure, floats have some weaknesses, like only being able to float elements to the left or the right of our page. However, using non-functional HTML elements like divs and spans, we can quickly set up scenarios where floating an element to the left of its container is essentially floating it to the center of another object. Thanks for watching. The number of users we can expect to view our website from mobile devices rather than the traditional desktop or laptop is increasing every year. Mobile devices employ a wide range of web browsers, some of which are very similar to traditional desktop web browsers, and others which are much more scaled down. For this reason, it's very important that we test any professional level product on as many devices as possible before putting it online for the world to see. This can be a daunting task, and one of the chief roadblocks here is getting all of these devices to test on. Fortunately, to test my new website on an Android phone and an iPhone and an iPad, I don't actually need to physically have all three of these devices. I can use what's called an emulator, which is software that I can run on my desktop or laptop machine that will act as though it was one of these devices. In this video, I'll be showing you how to access a web page that you've created as an HTML and CSS file from a mobile device emulator. For the methodology I'm going to show you here, we're going to need to acquire two pieces of software. The first of these is the emulator for the device we'd like to simulate. Our goal here, of course, is for this to be a general solution so that we can view our web page on any mobile device that has a freely available emulator, which is most of them. For this video, I'll be viewing our web page on an Android phone emulator. If you'd like to acquire this emulator, you should download the Android SDK. If you don't already have it installed, you may need the Java SDK as well for the emulator to run properly. Alternatively, you can freely download the emulator for any mobile device that you're comfortable with. When you're testing your web page before putting it online, you should test it in a number of emulators for a number of different devices. The second piece of software we're going to need is a web server. Because emulators simulate entirely new devices, they don't actually have easy access to the file system on our computer, where our HTML and CSS files are located. In my experience, the easiest way to give our device access to these files is to serve them on our local network. That's where the web server comes in. For this video, we'll be using the Mongoose bare bones web server because it's extremely simple to use. You can acquire this web server from this address, and we'll be working with the .exe download. The great thing about the Mongoose project is that it's extremely cross-platform. So even if you're not working in Windows like I am, your series of steps should be very similar to mine. Once you've downloaded the Mongoose executable, you're going to want to place it in the same file folder that your .html and .css files are. That's because we're not going to be modifying any of the Mongoose server's settings. We're simply going to be running it at its default. And this is the beautiful simplicity of the Mongoose server. If we simply run the executable, it's going to serve up the folder that it's located in. To make sure our web server is working properly, let's use our desktop web browser to quickly navigate to that served directory. We're going to instruct our web browser to navigate to that directory by giving it two pieces of information. First, it needs the IP address of the local machine. And we can always get that by simply using the localhost keyword. We follow that with a colon, and then we need to tell it what port we'd like it to request on. In this case, we're going to use port 8080. When we navigate to localhost 8080, we see an index of the contents of the directory that we launched mongoose.exe from. Included here is mobilepage.html, which is the website we'd like our emulator to be able to view. So let's close our traditional web browser. Mongoose server will continue running, continue serving up our local directory. You can see Mongoose server running in your Windows dock or operating system equivalent. And now, let's head back to our device emulator. I can't navigate my emulator to localhost like I did from my desktop machine. That's because localhost will navigate to this device itself, which believes itself to be completely separate from the Windows that is running it. Rather, I can use the IP address 10.0.2.2 to access the machine in which this emulator is running on. From there, we're once again going to navigate to port 8080. Port 8080 is the default port for a debug or development level server. If I submit that IP address, I will get my file system index back. And I'm going to zoom in a bit so we can actually see it. And there we go. There's mobilepage.html. All I need to do now is open that file and my web page will appear in our web browser, just as if we had double-clicked that file from the desktop of our Windows or whatever other operating system. This is the most efficient and general system I've discovered for viewing websites on many mobile devices. It's also the first step towards creating mobile-friendly websites, seeing how the websites look by default on mobile devices. Of course, creating mobile-friendly websites is a rather broad topic, so we're not going to be covering it right now in this video. Thanks for watching. In this video, we'll take a look at how we can have our mobile devices display different CSS rules than our traditional web pages. We'll be modifying the page in front of us to be more mobile device friendly. Let's start by taking a look at this page. It's pretty simple. It has two columns, which are div elements floated left and right. And then there's a header at the top of the page, which will display some links if we hover over it. This web page doesn't really do anything, but it's a pretty standard setup. Let's see what it looks like on a mobile device. On my Android phone emulator, this page is not so user-friendly. I can identify three major issues with it. First, this is the default view of the web page, how it will look when a user first navigates to this page. Everything on this web page is very small on this screen. It's simply too zoomed out for it to be readable. And we can change this pretty easily. The second issue I see is these left and right floated columns. Once we've zoomed in our page to a readable degree, the user has no way of knowing that there's something for them to view to the left or the right. This is a key idea behind mobile design, and as we'll see, even affects how some of the technology is laid out. Mobile web pages are expected to order vertically rather than horizontally. Lastly, our default web page expected users to mouse over this links section to see the links. In a professional finalized web page, these links would probably have appeared with some sort of animation to make the page look cool and cutting edge. Unfortunately, this is a really frustrating mechanic when it appears on your mobile device, because most of these devices use a touchscreen. That means in order to see these links, a user would have to press their finger on this box. Then that finger is either obscuring the links that are going to appear, or worse, clicking on one that was unintended. There's another semi-issue with this page that I'd like to talk about. The text in these left and right boxes doesn't encompass the entire area of the box. This has a two-part explanation. First, the mobile web browser in work here, which is a pretty standard mobile web browser, has done some styling of its own. Mobile web browsers will generally restrict the width of text elements so that users can see them at a reasonably zoomed in view in their entirety. Once again, users don't like scrolling left and right when viewing a mobile web page. The reason then that this text does not encompass this entire box is because we fixed the width of the box using a percentage of the max page width. Once again, this demonstrates that mobile web development is set up under the assumption that you're not going to apply fixed widths to your elements. So, assuming we like the way our web page displays on our desktop web browser, how then can we modify this page so that it displays in a more mobile-friendly view? There's really two options for us here. One, we can simply remove the CSS styling from this page when viewed on mobile devices. And while that sounds pretty radical, in a lot of cases where we don't want to expend the effort to create a brand new CSS sheet for mobile devices, it's a pretty good solution. Our other option there is to create a different set of CSS rules for our mobile device. We're going to be working to do this in the head of our HTML page. When we declare a style sheet in our HTML, one of the things we declare is for what type of media this style sheet should apply. We've always put screen there. That means that this style sheet applies to all media that has a screen, which is just about everything that's going to view your web page. The only real option that doesn't have a screen is media equals print, which is CSS that would apply when your page is printed. Another media option is handheld. And for a while, we could declare separate style sheets just by saying media equals handheld. And these style sheets would apply only for handheld devices. For better or for worse, this is not such a good solution anymore. As mobile devices and their web browsers become more and more powerful, more and more of these devices are choosing not to register themselves as handheld devices, because their local web browsers and their resolution is high enough that they can display high-end CSS effects with a reasonable degree. That doesn't mean, however, that we never want to target them with separate CSS. As we just saw, some pages just don't look good on the screen size of a mobile device. So how do we target them if they haven't registered as handheld? Generally, we choose to do it by taking a look at the width of their resolution. If they have a resolution below a certain width, we'll declare them to be handheld devices or small screened and write our separate CSS for them. In order to do this, we're going to need to do two things in our HTML. First, we're going to have to declare a meta tag. We name it viewport, and its content is a width, which is device width. This allows us to access the resolution width of the device viewing our web page. From here, we can change the nature of this media attribute. This is called a media query because we're asking the device for this information. Now, let's use this media query to remove our CSS styling from the mobile device we were looking at. A style sheet will apply to a device whenever this media value is true. So right now, this normal page.css style sheet applies to all devices with a screen. So in order to make our mobile device not eligible for this style sheet, we're going to have to make this media rule more restrictive. Let's say that in addition to the device having a screen, it must also have a certain device width. Here we need to choose a value. What device width is large enough for our web page to display appropriately? A number that's often used is 480 pixels for the threshold between a small device and a medium-sized one. If 480 pixels is a small device, then our minimum device width for having our stylized display is going to be 481 pixels. So let's go ahead and save this and take a look at our mobile device. When we refresh this page, the CSS styling on our page is removed because its device width is too small to trip the rule that says, go here and find yourself a style sheet. I would make the argument that this is a superior web page from the mobile point of view than the styled one. It's certainly not as pretty, but it's much more functional to the user. The links are easily accessible, and the user only needs to scroll vertically to read all of the text on the page. Jumping quickly to our browser on our standard desktop setup, when we refresh the page, we see that the old styling still applies because this web browser did trip the min device width rule that we just wrote. Now, let's say that we'd like our mobile website to still look thematically similar to our larger version. In order to do this, we're going to write separate CSS for our mobile site. So we're going to need a new HTML style sheet rule. We're also, of course, going to need a new style sheet. And I've gone ahead and created a brand new blank CSS style sheet, mobilepage.css, in the same directory. So, our new style sheet rule is going to link to this mobilepage.css rather than the normal page we were using beforehand. And now we're going to want to modify this media rule so that it will trip for devices with small screens. Well, we'd like one of these two rules to apply in all cases. So we can simply switch the min value of this statement to max. Now we'll apply to devices up to a width of 481 pixels rather than devices with widths of 481 pixels and above. Of course, we do need to make one modification because devices with a width of exactly 481 pixels, which is unlikely, will trip both of these rules. We can safely set our max device width to 480 pixels, one less, because no device can have a width of 480 and a half pixels. Now, let's go, after we save this, to our mobilepage.css, which we have linked to for small devices. We're going to give this page a rather obvious CSS rule so that we can simply see if it's working. We'll set the background color of our header to red. And while we're here, we should observe some best practices. We're going to surround all the CSS on our mobile page with this media rule. And we're going to give as its value the defining media rule that we declared for our small devices. And then we're going to surround all of the CSS on our page with this rule. This is a form of what we call dinosaur protection. What we're preventing against is very old web browsers going through and seeing this mobile targeted CSS page rule and reading the media query and saying, screen, I've got that. Max device width, I don't know what that means, but I'll accept it anyway. Which is a behavior we see in some older web browsers, simply because they weren't programmed to expect these values. However, it's very unlikely that these web browsers, once they've mistakenly navigated to our mobile CSS page, will then read this in CSS rule and assume that they fit the criteria here as well. That's because the standard operating procedure in CSS is to ignore rules when you don't understand them. Of course, any device that tripped the original max device width of 480 pixels and was supposed to will also understand this second media query. So let's take a look at our mobile device, which is hopefully now using this extremely short CSS page. So we'll go ahead and refresh our web page here. And we see that the links, which is the header element of the page, now has a red background. All right, now we could go through this mobilepage.css and essentially recreate the CSS in this normal page without all of the attributes that we don't want. But that would be a little tedious. Generally, when we're setting up a web software project and we know that we're going to support both desktop browsers and small device browsers, we're going to write 3 CSS pages. In addition to this normal page, which we would probably call something like large page from the start, in our mobile page, we're going to have a base or basic page, which is CSS that we'd like to apply across all cases. In this case, things like the background color of our elements. so that our web page has a style that arcs across all of the other size-specific pages that we write. So let's target this base page that I've taken the liberty of creating, empty, in our HTML. We're going to, of course, write a third style sheet rule for it. And because of the nature of this page, we'd like this rule to apply in just about every case, or all cases in which the viewing device has a screen. And we need to target our CSS rule to it. And while we're at it, let's get rid of screen in the media queries of our other two rules, just so we're not being redundant. Now, we're going to be moving a bunch of the CSS from this normal page over to the base page. For the sake of expediency, since we're just doing a video here, we're not going to be deleting the CSS from the normal page. Ideally, if you're building a project, you're going to work originally from the base page to outline the general styling of your web page. If you were moving from the normal page to the base page like we're doing right now, you would probably want to delete the general CSS from the normal page after you move it. But we're just going to leave it on the normal page, and there'll be redundant rules, but it'll display just fine. I think we're going to want some CSS from the header rule in all cases, some CSS from our column rules in all cases, and some CSS from these lists in all cases. Now, let's get into the nitty-gritty and talk about best practices for mobile web styling. We talked earlier that the general rule for mobile development is that you never want to, if you can help it, explicitly set widths. We saw that explicitly setting the widths of our column both removed the mobile web browser's ability to accurately judge how wide it can make text for easy viewing and reading, and also generally caused our page to have a horizontal axis to it, which we generally want to avoid with web development. So let's get rid of our width rules. Now we have to make the decision of, do we need our columns to be ordered left and right, or can we just stack them on top of each other like they are in the unstyled page? Assuming that it's not integral to the nature of our page that these columns be left and right, I think we should remove the floating and let them stack on top of each other so that users can view our page simply by scrolling up and down. Let's look at the rest of the styling in these columns. They have a background color, a border, and a border radius. This is just visual, and it's what gives our page its unique flair. Keeping this will cause our mobile page to still look like it was cut from the same stuff as our larger version of the page. Border radius is a CSS3 property, so it might not be supported in all major web browsers, and there's certainly some smaller mobile web browsers that aren't supporting border radius. I don't think it's a problem to leave it in here though, because our page is not going to be unreadable if the border radius doesn't show up. On our horizontal list, let's just get rid of the borders for our list items because it'll look funny if we leave them in. Let's save that and take a quick look in our web browser to see how we're doing. So we left the background coloring for the header in, which looks a little odd. Our links are still displaying horizontal, and we're probably going to need to fix that because it causes them to wrap around for the new line. But otherwise, we're doing pretty well. let's go fix those issues very quick. One of the problems we just saw with the linked list, not a linked list, the unordered list, is that our header doesn't really encompass them properly. That's because we've explicitly set a height. We can go ahead and remove the height and let our web page determine the height for itself. Now, our lists are displaying horizontally, and we don't want that. The reason our lists are displaying horizontally is because we explicitly asked the list items to display inline. If we remove that, they should stack vertically like they did on the unstyled page. Probably we should change this rule to something besides horizontal list in case someone else ever looks at our code, but for now it'll work just fine. Let's go back and refresh again. And there we go. Aside from the red block that we didn't remove, I would say this is a very mobile-friendly web page. And it retains a lot of similar visual styling that our larger version of the page did. This means that users who are used to our large version page and then navigate it to it on a handheld device will still feel comfortable that they're in the right place, and vice versa. And that's the basics of mobile targeted websites. To kind of browbeat this mobile devices are the next big thing point, a quick web search informed me that in May of 2012, mobile devices made up 20% of all web traffic. From a commercial point of view, we also know that users on a mobile device are more likely to be navigating to a website with a specific purpose in mind. That means that your mobile traffic is very interested in purchasing your product or consuming your service right here and right now, and you don't want to miss out on that. So thank you for watching, and best of luck converting your websites.